Under ancient skies, before city lights stole the darkness, our ancestors gathered and looked up in wonder. They saw the night come alive with countless stars, a glittering band of light arching from horizon to horizon. In that quiet darkness, they traced patterns in the stars and told stories about heroes and gods who lived in the heavens. The sky was a source of mystery and meaning. Each point of light beckoned with a silent promise, stirring dreams of worlds beyond our own. From desert camps to mountain villages, people felt the pull of the cosmos. They imagined mighty beings moving the sun and moon, and believed their fortunes were written in the stars. On clear nights, the Milky Way spilled across the sky like a river of glowing embers. Our ancestors whispered myths about how the world began and what wonders lay above the clouds. The heavens were a grand tapestry, and every culture wove its own legends among the constellations, filling the darkness with stories and hopes. For millennia, the boundary between earth and sky seemed absolute. Birds flew through the air, but no human could follow. The blue sky in daytime and the star-filled dome at night remained unreachable realms. Yet the desire to touch the sky never faded. Children watched birds and wondered how it would feel to soar. Elders watched the changing moon and dreamed of what might be on that silver disk hanging in the night. Across generations, these celestial dreams became part of what it means to be human. Softly, over crackling fires, elders recounted tales of brave souls who attempted to reach the heavens. There were legends of mortals carried aloft by swans or angels, and of clever artisans who crafted wings of feather and wax. In one Greek myth, a young man named Icarus flew with wings his father made. But when he soared too close to the sun, the wax that held his wings melted and he fell back to earth. Such stories carried warnings, yet also a tantalizing hint of possibility. If only we could fly high enough, perhaps we could touch the stars. On the other side of the world, by the light of paper lanterns, people in China told of a woman named Chang Yi, who drank a magic elixir and floated all the way up to the moon. They imagined her living there forever, with only a white rabbit as her companion, gazing down at the world she left behind. There was even a legend of an official named Wan Hu, who fastened dozens of rockets to a chair and lit them, hoping to blast himself into the sky. His fate is lost to myth, but the tale shows how deep the longing ran to break free of Earth's grasp. Across continents and centuries, similar dreams took shape. Flying chariots, crystal palaces among the stars, even great towers or stairways reaching toward heaven. For thousands of years, such dreams stayed in the realm of myth and fantasy. Humanity was bound to the ground. The sky was for birds and gods. Still, we studied the heavens with patience and wonder. Ancient astronomers in Babylon and Greece tracked the wandering planets and predicted eclipses, seeking patterns in the sky's grand clockwork. In Egypt, great pyramids were aligned with the North Star, anchoring our monuments to the cosmos. At Stonehenge and other sacred sites, stones were arranged to mark the rising sun and the cycles of the moon, tying the rhythms of Earth to the motions of the heavens. Navigation too depended on the skies. Sailors steered by the stars across uncharted seas, and even without leaving the ground, we reached toward the stars with our curiosity, our calculations, and our monuments. Over time, our knowledge of the sky deepened. We learned that Earth itself is a celestial body, a planet moving among stars. Early telescopes revealed mountains on the moon, and moons orbiting Jupiter, proving that the heavens held other landscapes, other worlds. The more we discovered, the more our wonder grew. But for all our learning, actual flight beyond Earth's reach remained a distant dream. We invented kites that danced on the wind. We soared in hot air balloons above the treetops, and in time we built airplanes that let us conquer the open sky. Yet even the highest flying plane could only graze the edge of Earth's atmosphere. The stars beyond remained cold and unreachable, shining down as they had for eons. To venture into space, we would need something new, something powerful enough to break free of gravity's grip. The answer would emerge from that same spark of imagination that fueled the old legends. It arrived in the form of the rocket, a bold idea that had smouldered in minds for centuries and was finally ready to ignite into reality. Throughout history, rockets had been used as fiery arrows in celebrations and war, but never to carry a person above the sky. The Chinese invented simple gunpowder rockets centuries ago, delighting crowds with fireworks and terrifying armies with flaming projectiles. Yet the notion that a rocket might one day break the bounds of Earth and reach space was long seen as fantasy. Such ideas remained in stories and early science fiction, waiting for the right minds to make them real. In the late 19th and early 20th century, a few visionaries began to turn those wild ideas into a science. In a quiet provincial town in Russia, a schoolteacher named Konstantin Tsiolkovsky pored over equations and imagined space travel on paper. He wrote of multi-stage rockets that could escape Earth's gravity, and even pictured space stations orbiting our planet. It was Tsiolkovsky who declared, "Earth is the cradle of humanity, but one cannot remain in the cradle forever." Those words captured a profound belief that humanity would one day grow beyond its home world. At a time when no rocket had yet left the ground, he laid down the mathematical foundations that others would build upon. Far across the ocean in the United States, an inventor named Robert Goddard was working steadily to bring rocketry out of theory and into reality. For years, Goddard experimented in solitude, constructing odd metal cylinders and firing them in open fields. Neighbors often heard bangs or saw trails of smoke and thought his quest was folly. But Goddard persisted. On a cold March morning in 1926, on a farm in Massachusetts, he ignited a slender rocket fueled by gasoline and liquid oxygen. With a sputter and a roar, the rocket rose barely 40 feet into the air and fell. But it was a triumph, the first successful flight of a liquid-fueled rocket. What had been a mere curiosity was now a working technology, albeit in its infancy. Step by tiny step, the age of space travel was coming alive. In Europe, rocketry was also gathering steam. A Romanian-born physicist named Hermann Oberth published a book in 1923 that excited the public with the possibility of travel beyond the Earth. His writings inspired young engineers and enthusiasts, leading to the formation of rocket societies in Germany and elsewhere. In garages and workshops, they built and tested rockets, learning from each launch and explosion. One enthusiastic rocketeer was a German teenager named Werner von Braun, who would later become pivotal in designing the great rockets of the space age. Back then, he and his peers were dreamers, setting off small rockets in the countryside, watching them streak upward and imagining they might one day reach the stars. By the mid-20th century, rocketry had made great strides, accelerated by the pressures of global conflict. During World War II, rockets were turned into weapons. The German V-2 missile, spearheaded by that same Werner von Braun, became the first man-made object to travel into the fringes of space during its high-arcing flight. It struck with destructive force, a far cry from the peaceful aspirations of the early pioneers, but it proved what rockets could do. When the war ended, the knowledge of rocketry did not vanish. Instead, engineers and scientists carried it forward, many of them hoping to use this powerful technology for exploration rather than destruction. In the years immediately after the war, Captured V-2 rockets were tested by American and Soviet teams, giving engineers hands-on experience with large rockets. In 1946, one such V-2 launched a camera high above Earth, snapping the first photographs of our planet from the edge of space. The grainy black and white images showed the curvature of Earth against the blackness beyond. A first glimpse of what one day astronauts would see with their own eyes. It was a preview of the perspective that would later profoundly move those who eventually orbited Earth. It was astonishing how quickly things progressed. Only a lifetime earlier, in 1903, the Wright brothers had achieved the first powered airplane flight, soaring for just seconds over the dunes of Kitty Hawk. And now, by the late 1940s, rockets were touching the very edge of space. Technology was catching up to the ancient dreams, and a new chapter was poised to begin. The stage was set for a new kind of endeavour, one that would pit nations and ideals against each other in a race to conquer the final frontier of space. Not long after these developments, a new rivalry took shape, not on battlefields, but in the realm above the sky. In the late 1950s, the world's two superpowers, the Soviet Union and the United States, turned their eyes to space. Each was determined to be the first to conquer this new frontier, and their competition became known as the space race. It was a contest driven by political pride and technological prowess, but it captured the imagination of people all over the globe. The starting gun was fired in October 1957, when the Soviet Union achieved a stunning first. They launched the world's first artificial satellite into orbit. It was called Sputnik, a shiny metal sphere no bigger than a beach ball, and it circled Earth emitting a simple, repetitive radio beep. That sound, picked up by radios worldwide, sent shivers through all who heard it. People stepped outside and gazed upward, trying to spot the tiny moving dot racing among the stars. Sputnik's success marked the dawn of the space age. Humanity had placed its first object in space. In that moment, the endless sky we had watched for millennia was no longer beyond our reach. Our machines were now among the stars, if only just. The Soviet achievements continued at a rapid pace. A month after Sputnik, they sent a living creature into orbit, a small dog named Laika. She became the first animal to travel around the Earth, a brave pioneer on behalf of humanity. Though Laika's journey was one way, it proved that life could survive, at least briefly, in the weightlessness of space. The door was opened for human explorers. The world did not have long to wait. On a cool April morning in 1961, a new voice crackled down from the heavens. "Poyakali," a young Soviet cosmonaut exclaimed at launch. "Let's go," as he embarked on a voyage no person had taken before. His name was Yuri Gagarin, and he was about to make history as the first human in space. Gagarin's Vostok spacecraft roared into the sky atop a pillar of flame, and for 108 minutes he circled the Earth. In that short flight, he beheld our planet from the outside. "I see Earth. It is so beautiful," he radioed back, marveling at the sight of his home world glowing below him. When Gagarin safely parachuted down after his single orbit, he was met with astonished joy. All across the planet, people hailed him as a hero of a new age. It was as if, for a moment, the entire world united to celebrate one human being's journey beyond the cradle. The United States, eager to catch up, quickly accelerated its own efforts. Less than a month after Gagarin's flight, American astronaut Alan Shepard climbed into a tiny Mercury capsule perched atop a Redstone rocket in Florida. His mission was shorter, just a 15-minute suborbital hop out of the atmosphere and back down. But when Shepard splashed down safely, he became the first American in space. The following year, in February 1962, John Glenn became the first American to orbit the Earth. Squeezed into a capsule barely large enough to hold him, Glenn circled the globe 3 times. As he passed over night and day, continents and oceans, he became another set of eyes and ears for all humanity in the cosmic ocean. Television and radio carried these events live to millions, and a sense of shared destiny began to grow. People worldwide were learning the names of these astronauts and cosmonauts, and following their exploits with held breath and hopeful hearts. One by one, barriers fell. The Soviets sent the first woman, Valentina Tereshkova, into space in 1963. She spent 3 days orbiting Earth, proving that space was open to all of humanity, not just men. In 1965, cosmonaut Alexei Leonov took a bold step into the void, literally stepping out of his spacecraft to conduct the first spacewalk. Tethered to his ship, Leonov floated in the vacuum, the Earth sprawling beneath him, demonstrating that humans could survive and work outside a spacecraft in a pressurized suit. It was not easy. His suit ballooned with the pressure, and he had to struggle to get back inside. But he succeeded. Soon, the American astronaut Ed White performed a similar spacewalk, delighting in the surreal experience of floating freely above the blue Earth. Each new milestone was like a chapter in an adventure story, and the world followed along in wonder. As missions flew, both nations learned more about how to live and work in space. The American Gemini program, following Mercury, sent 2 astronauts at a time into orbit and taught them to maneuver their craft, rendezvous with other vehicles, and endure longer flights. In one Gemini mission, 2 astronauts spent nearly 2 weeks in space, circling Earth again and again to test the limits of human stamina in zero gravity. They practiced docking their spacecraft with a target vehicle, an essential skill for any future lunar voyage. Through these efforts, what had once been a sprint became more of a marathon, as spacefarers gained experience and confidence. Yet the ultimate goal of this great race lay further ahead. In 1961, even before the Americans had achieved an orbital flight, President John F. Kennedy issued a daring challenge: to land a man on the moon and return him safely to Earth before the 1960s were over. At the time, it seemed almost impossible. No one knew exactly how to do it. But the challenge was accepted, and it galvanized NASA, the American Space Agency, into action. An enormous program named Apollo took shape, drawing on thousands of engineers, scientists, and astronauts. They designed new spacecraft and gigantic rockets more powerful than any seen before. They studied the moon, trying to choose safe landing sites. Every mission, whether Soviet or American, was watched with an eye toward the moon, that ancient beacon in the sky that had beckoned for so long. The mid-1960s were a period of intense preparation. There were setbacks and even tragedies as the learning process was paid for in risk. But by 1968, the Apollo program was nearing its culmination. The rocket that would take astronauts to the moon, the towering Saturn V, had been tested, its roar shaking the ground for miles around and its fiery trail piercing the heavens. The spacecraft that would carry and land the crew had been built and refined through trial and error. The stage was set. Humanity was ready at last to set foot upon the moon, turning the ancient dream into reality. On the days before Christmas in 1968, the world witnessed a preview of the lunar triumph to come. Apollo 8 became the first crewed spacecraft to leave Earth orbit and travel to the moon. 3 astronauts rode the new Saturn V rocket's Inferno and headed outward, trading the gravitational pull of Earth for that of the moon, As they swept around the moon's far side and regained radio contact, humanity heard something never heard before. Voices coming from lunar orbit. On Christmas Eve, the Apollo 8 crew took turns reading an ancient passage about the creation of the world, their voices crackling across 250,000 miles of space to radios and televisions back on Earth. During that mission, astronaut Bill Anders captured a photograph that would forever shape our perspective. Earthrise. In it, the distant blue Earth is seen rising above the moon's grey horizon, a fragile oasis of life in the darkness of space. That image stirred hearts around the globe. It was as if Apollo 8 had not only scouted the path for landing on the moon, but also delivered to us a gift, a new way to see ourselves. Less than a year later, it was time for the long-awaited leap. In July 1969, Apollo 11 thundered into the sky on its voyage to the moon. Millions of people around the world followed every moment. After 3 days in transit, the spacecraft neared its destination. Astronauts Neil Armstrong and Buzz Aldrin squeezed into a small, spidery landing craft named Eagle and undocked from the command ship, which was left orbiting with a third crewman, Michael Collins, aboard. As Eagle descended toward a broad, dusty plain called the Sea of Tranquility, the tension on Earth was palpable. The landing was not without challenges. A computer overload triggered alarms, and the site they were aiming for was strewn with boulders. With calm focus, Armstrong took manual control, steering past the hazards as fuel ran low. Then, at 4:17 p.m. Eastern Time on July 20th, 1969, a quiet message arrived. Houston, Tranquility Base here. The Eagle has landed. Relief and jubilation erupted in mission control, and across the world people cheered, cried, and hugged each other. Humans had arrived on the moon. Several hours later, as the moon hung high in the sky over Earth's night side, Neil Armstrong opened the hatch and descended the ladder of the Eagle. Clad in his white suit and helmet, he paused on the last rung. The world held its breath. Then he took that final step, placing his boot gently onto the lunar soil. "That's one small step for man," Armstrong spoke, his voice calm but carrying immeasurable significance. "One giant leap for mankind." Live on television, a grainy black-and-white image showed his ghostly figure setting foot on another world. In that instant, the dreams of countless generations had become reality. Down on Earth, it was late at night, or early morning for many, but millions were transfixed in front of their TV sets, gathered in homes, schools, and public squares. Some people stepped outside to look up at the moon itself, marveling that 2 of our species were standing there at that very moment. A collective sense of achievement and wonder swept across humanity. Buzz Aldrin soon followed Armstrong out onto the moon's surface. Together, the 2 men spent about 2.5 hours exploring in the lunar sunlight. They moved slowly, learning to walk in the moon's weak gravity, which was only 1/6 of Earth's. Each step sent them bounding in a slow-motion lope. The only sounds were the ones they carried with them inside their suits, the soft whir of pumps, the radio crackle of distant voices from Houston, and their own breath. All around was silence. There was no atmosphere on the moon to carry sound. The landscape was otherworldly, a grey desert of powdery dust and rocks, stretching to gentle hills at the horizon under a sky as black as night. Aldrin described the scene as magnificent desolation. They set up experiments to measure the moon's environment, took photographs, and collected rock samples to bring back home. At one point, they paused and planted a flag of the United States. Its fabric had been stiffened with thin rods so it would stand out in the airless sky. In doing so, they made clear this was not a conquest by one nation, but a step forward for all humanity. Before leaving, they left behind a plaque on the landing leg of their craft that read, We came in peace for all mankind. When their work was done, Armstrong and Aldrin returned to the Eagle lander and lifted off to rejoin Collins, orbiting above. The three began the long journey home, carrying with them samples of lunar rock and soil, the first pieces of another world ever brought to Earth. They splashed down in the Pacific Ocean, and for a moment it seemed the whole planet celebrated. Parades greeted the astronauts in cities across continents. They were feted as heroes, not just of one country, but of the entire human race. For a brief time, people everywhere felt a bit closer, joined by the realization that we had done something truly incredible together. In the following years, 5 more Apollo missions journeyed to the moon, each one built on the last, staying longer and probing farther. Apollo 12 landed amid an eerie, silent plain, not far from an old robotic probe that had arrived years before. Apollo 13 suffered a dangerous explosion en route and had to loop around the moon without landing. But thanks to ingenuity and courage, the crew returned safely, an exploration drama that showed the perils involved. Apollo 14, 15, 16, and 17 each brought new surprises. Astronauts drove a little electric lunar rover on the later missions, bumping across craters and hills and laughing at the novelty of a road trip on the moon. They collected more rocks, set up scientific instruments, and even performed a few playful antics, like hitting a golf ball that sailed far in the low gravity. With each mission, we learned more about our celestial neighbor and about what humans could do on an alien world. The final Apollo mission, Apollo 17, departed the moon in December 1972. Before climbing the ladder to leave the lunar surface, Commander Gene Cernan reflected on the moment. He said, "We leave as we came, and, God willing, as we shall return, with peace and hope for all mankind." Then he and his crewmate lifted off, watching the lunar module's engine fire turn the grey dust golden beneath them. No humans have walked on the moon since that day. In total, 12 men left their boot prints on the lunar plains, and those footprints are likely still there, undisturbed in the moon's airless calm. They may remain for millions of years as a reminder of what was achieved. Back on Earth, Apollo's legacy endures in countless ways, from the scientific knowledge gained to the inspiration it sparked in generations to follow. We proved to ourselves that no dream was too distant, no goal unattainable, if we set our minds and hearts to it. The excitement of the moon landings eventually began to fade, but humanity's push into space took a new turn. Having proven we could visit another world, we now turn to the challenge of living in space, staying for longer periods, and learning to make a home beyond Earth. The era of the space station had begun. In 1971, the Soviet Union launched Salyut 1, the world's first space station. It was a small cylinder orbiting high above, but it marked the first time people could call a place in space home, even if only for a few weeks at a time. Cosmonauts flew up in their Soyuz craft, docked with Salyut, and lived aboard this outpost among the stars. Inside Salyut 1, 3 men floated in a space not much larger than a train car, conducting experiments and observing Earth through portholes. Their stay was short, but it proved that astronauts could live and work in orbit, not just visit it briefly. A couple of years later, in 1973, the United States launched its own orbital workshop called Skylab. Skylab was built from a modified rocket stage, making it roomy by space standards. Astronauts could even do somersaults in the open living area. Across 3 different missions, teams of astronauts occupied Skylab, setting new records for time spent in space. They lived and worked aboard for weeks, then months, showing that humans could endure and stay healthy during extended periods off Earth. Inside Skylab, they performed scientific experiments, observed the sun through a special telescope, and watched our weather systems swirl below. Day-to-day life required adaptation. They ate meals floating around a table, using Velcro to keep utensils from drifting away. Sleeping called for strapping themselves into sleeping bags tethered to the walls so they wouldn't drift about. One crew even managed to improvise a shower, a plastic curtain and bag setup, enjoying the novelty of a weightless wash. But alongside moments of levity, there was plenty of hard work. Astronauts on Skylab studied the effects of microgravity on their own bodies, grew plants to see how life from Earth fared without gravity, and fixed equipment while floating in bulky spacesuits. One crew stayed aboard Skylab for 84 days. When they finally returned to Earth in 1974, they had shown that humans could live in orbit for nearly 3 months and come back strong. As the 1970s continued, the Soviet space program forged ahead with its series of Salyut stations. Each new station improved on the last and hosted multiple crews over several years. Cosmonauts gradually pushed the duration of missions further, first a month, then a few months at a time. They began to learn the rhythms of living in orbit, the routines of maintenance and scientific work, the importance of exercise to combat muscle and bone loss, and the psychological challenge of being confined in a small space far from home. They looked down at Earth and noted how thin our atmosphere appeared, just a delicate film around the planet. Every mission taught them something new about keeping a crew safe and healthy in space. There were difficult moments too, including emergency landings and equipment failures. But with each challenge, the crews grew more adept at surviving and solving problems in the void. In 1975, a remarkable moment hinted at a new era of cooperation beyond Earth. An American Apollo spacecraft was launched not toward the moon, but to rendezvous with a Soviet Soyuz capsule in orbit. When the two vehicles docked, their hatches opened, and Apollo commander Tom Stafford and Soyuz commander Alexei Leonov reached out and shook hands. Floating there, half in one ship and half in the other, they smiled for the cameras and for history. For 2 days, the American and Soviet crews visited each other's spacecraft, shared meals, exchanged flags and gifts, and conducted joint experiments. This Apollo-Soyuz mission took place while Cold War tensions still existed on Earth, but high above, former rivals worked as partners. It was a brief encounter, but it showed the world that in space, cooperation was possible, even between nations that were adversaries on the ground. It planted a seed that would bloom years later into a fully international approach to living in space. That spirit of partnership took on new life in the late 1980s and 1990s. The Soviet Union launched a new type of station named Mir, which means peace or world in Russian, in 1986. Unlike the one-piece Salyuts, Mir was modular. It began with a core unit, and over time, additional modules were added, like building blocks in orbit. As it expanded, Mir became the first truly long-term inhabited space outpost. Cosmonauts didn't just visit Mir, they lived there for months, and the station was continually occupied for almost 15 years. Inside, Mir had cramped corridors filled with equipment, cables, and the essentials of daily life. Crews of 2 or 3 at a time settled into a routine of scientific research and station upkeep. Life on Mir demanded ingenuity and resilience. Resources were limited, water was recycled, and supply ships periodically brought food, spare parts, and letters from home. The cosmonauts grew small gardens of wheat and vegetables, delighted to see green sprouts in the artificial light, a tiny patch of life in a metal habitat surrounded by vacuum. Exercise was a daily necessity. They ran on treadmills with bungee cords strapping them down and pedaled stationary bicycles to keep their bodies strong. There were also unexpected challenges. At one point, a small fire broke out on the station, filling it with smoke that the crew had to desperately filter out. On another occasion, an arriving supply spacecraft collided gently with Mir, puncturing a module and causing air to leak. The crew sealed off that section and carried on, later repairing the damage. Through it all, they demonstrated calm and resourcefulness. One cosmonaut, Valery Polyakov, spent 14 continuous months aboard Mir, setting a record for the longest single spaceflight. When he returned to Earth in 1995, he had shown that a human could live in microgravity for well over a year, an important proof of endurance for any future journeys to Mars. Meanwhile, the United States had embarked on a different path to space habitation with the Space Shuttle program. Starting in 1981, the winged shuttles began ferrying astronauts and cargo to orbit on a routine basis. The shuttle missions were shorter, generally 1 to 2 weeks long, but they were frequent and versatile. Shuttles carried satellites to orbit, serviced observatories like the Hubble Space Telescope, and conducted science experiments in a pressurized module in the cargo bay. The idea of reusing spacecraft became reality, as the same shuttles flew multiple missions. Perhaps most importantly, the Space Shuttle laid the groundwork for assembling and supplying large structures in orbit. In the 1990s, a significant partnership formed between former competitors. The United States and Russia, which had inherited the Soviet space program, decided to cooperate on a series of missions. American shuttles began visiting the Mir space station, carrying US astronauts who would stay aboard Mir alongside Russian cosmonauts. These joint missions were a learning experience for both sides. American astronauts got a taste of long-duration spaceflight, adapting to life on Mir for months, while Russian engineers benefited from the shuttle's capacity to bring up larger supplies and parts. The Shuttle Mir program, as it was called, built trust and helped both nations develop common procedures that would be essential for the next big project on the horizon. By the end of the 20th century, that project was taking shape: the International Space Station, or ISS. Unlike any station before, the ISS was a global enterprise. The United States, Russia, Europe, Japan, and Canada all pooled resources, parts, and expertise to create a single orbital laboratory that would dwarf all previous stations in size and capabilities. Construction began in 1998. A Russian Proton rocket launched the first module, and soon after, the Space Shuttle delivered an American module to attach to it. Piece by piece, over more than a decade, the ISS was assembled in orbit. It became a sprawling complex with solar panel wings spanning the length of a football field and living quarters and labs the size of a large house. Building it was an intricate dance. Astronauts and cosmonauts performed countless spacewalks, bolting together segments, connecting cables and cooling lines, and gradually turning a collection of separate modules into a single unified station. Inside, laboratories from different countries were outfitted with scientific equipment. Over time, the station gained areas for the crew to sleep, a kitchen corner for preparing meals, exercise machines, and even a small module with a 360-degree view of Earth called the cupola. By the early 2000s, the International Space Station was open for business. Since late 2000, the ISS has been continuously inhabited. For over 2 decades now, there has never been a moment when humans were not living off the Earth. Typically, a crew of 6 lives on the ISS at any given time, rotating every half year or so. They come from a range of countries and backgrounds, reflecting the station's international nature. Life in this orbiting laboratory has a rhythm that by now is almost ordinary. The crew wakes up, according to Greenwich Mean Time, to keep a standard schedule, and begins their day with planning and breakfast floating around a table. Throughout the day, they work on science experiments, maintain the station's systems, and communicate with mission control teams around the world. Each astronaut spends about 2 hours every day exercising, an essential routine to prevent the muscle and bone loss that occur in microgravity. They pedal on a stationary bicycle, which has no seat since they don't need to sit, run on a treadmill while a harness holds them to the moving belt, and lift weights on a resistance machine that uses vacuum cylinders to simulate weightlifting. Keeping fit is not just about health. It's necessary so that when they eventually return to Earth's gravity, they can walk again and recover quickly. In their free time, astronauts might watch a favorite movie on a laptop or read books that they brought along. There's often camaraderie during meals, as the crew comes together to share rehydrated or thermostabilized dishes, perhaps a special treat sent up from home, or an international night where everyone tries each other's cuisine. Some crew members enjoy playing music. There's a guitar on board, and it has floated through many hands, while others spend time simply gazing out the windows. And what a view it is! From the ISS's cupola, a dome-like module with multiple windows, the Earth reveals itself in breathtaking splendor. Astronauts peer down at daytime scenes of bright blue oceans and quilted green-brown continents, and at night they see cities twinkling like stars on the land below. Every 90 minutes, the station completes an orbit, which means the crew experiences a sunrise or sunset 16 times a day. They often witness phenomena that few on the ground ever could. Curtains of green auroras shimmering over the polar regions, gigantic storms swirling over oceans, and lightning flickering in thunderstorms far below. Against the infinite black of space, they see the thin, luminous band of Earth's atmosphere hugging the planet, a reminder of how delicate our home's protective blanket truly is. These sights tend to leave a lasting impression. Many astronauts come back with a deep sense of Earth's beauty and fragility, a feeling that fuels their desire to protect our planet. Floating 250 miles above the surface, the astronauts aboard the ISS also remind us that living beyond Earth is no longer just a dream or a short adventure. It's something we're doing continuously. More than 500 individuals from dozens of countries have now traveled to space, and a good number of them have called the space station home for a while. The ISS stands as a testament to what humanity can accomplish when we work together. Research on the station has taught us how to recycle air and water efficiently, how to grow vegetables in microgravity, and how human bodies adapt over long periods without weight. All of these lessons are helping to prepare us for future voyages deeper into space, whether to the Moon, Mars, or beyond. If you step outside on a clear night at the right moment, you might even see the space station pass overhead. It appears as a bright, fast-moving star sliding silently among the real stars. In that silent gliding speck of light, there are people. Perhaps at that very moment, one of them is looking down toward you, sharing the connection across the darkness. Seeing the station with your own eyes can give you a small thrill, a realization that humanity has extended its presence into the sky. We have one foot planted on our home world and another, figuratively, in the cosmos. The boundary between Earth and space has become, in a tiny but significant way, a livable frontier. Step by step, we are becoming citizens of two realms, the ground beneath our feet and the space just beyond, each enriching the other as we continue our Odyssey. By the turn of the millennium, humanity had learned how to live in space, just above our planet. Naturally, the question arose, where to next? The same spirit that drove us to the moon and kept us in orbit now inspired us to set our sights on farther horizons. Chief among these was Mars, the red planet that has long captured our imagination. Ever since telescopes first revealed its rust-coloured deserts and polar caps, Mars has been a fixture in our dreams of exploration. In the late 20th century, even as Apollo was winding down, NASA planners and space visionaries were sketching bold plans to send humans there. Werner von Braun, the rocket engineer behind Saturn V, envisioned giant spacecraft carrying dozens of explorers to Mars as early as the 1980s. Others imagined a permanent lunar base by the end of the 20th century, which would serve as a stepping stone to the rest of the solar system. Those early plans never materialized. Technical challenges and budget realities kept them on the drawing board, but they planted a seed for the future. Meanwhile, science fiction writers and artists continued to stoke the public's imagination. Movies and novels depicted spacefaring civilizations with colonies on the Moon and Mars, spinning wheel-like space stations with artificial gravity, and voyages to Jupiter and beyond. These stories, though fictional, kept alive the idea that pushing further out into space was not only possible, but perhaps inevitable. In the 1970s, Princeton professor Gerard O'Neill proposed concepts for enormous space habitats, miles-long cylindrical colonies orbiting Earth, where tens of thousands of people could live in artificial gravity created by the cylinder's rotation. Inside, he imagined, there would be blue skies and clouds, green parks and farmland, even small lakes, all contained within a vast curved interior landscape. Such visions were breathtaking, self-contained worlds floating in the void, offering humanity new places to call home. These concepts remain theoretical, but they influence how we think about living off Earth, even today. As the 21st century dawned, our continued presence in orbit and rapid advances in technology began to turn some of those dreams into concrete plans. After decades focusing on low Earth orbit, national space agencies and private companies alike started looking outward again, to the Moon, to Mars, and beyond. The Moon, our closest celestial neighbour, emerged as a clear next step. Several nations announced intentions to return astronauts to the lunar surface, this time not just to visit, but to stay for longer periods. Engineers sketched out landers and habitation modules that could survive the 2-week-long lunar night and make use of resources found on the Moon itself. One idea gaining traction was to target the Moon's south pole, where deep craters contain water ice preserved in eternal shadow. That ice could be mined and converted into water for drinking, oxygen for breathing, and hydrogen for rocket fuel. A permanent outpost might be established there in the not-too-distant future, with astronauts rotating in and out, and perhaps one day families joining them. Living on the Moon, once purely the stuff of fiction, now sits on the horizon as a very real possibility. Mars remains the most tantalizing prize for human exploration. Roughly half again as far from the Sun as Earth, Mars is a cold world of iron-rich dust, craggy mountains, and vast canyons. It's harsh and barren today, but evidence gathered by robotic rovers suggests that in the distant past, Mars had rivers, lakes, and possibly a thick atmosphere, conditions that might have supported life. Sending humans to Mars is a challenge of unprecedented scale. It requires a journey of 6 to 9 months each way, advanced life support systems, protection from space radiation, and the ability to land safely on a planet where the atmosphere is too thin to slow a spacecraft much, but thick enough to complicate the descent. Despite the difficulties, there is a strong momentum building toward making it happen. Space agencies have drafted roadmaps that see humans on Mars, perhaps in the 2030s or 2040s. Ambitious private companies are also developing massive rockets and spacecraft with the explicit goal of reaching Mars and establishing a foothold there. The prospect of humans walking on the red planet no longer feels like a vague someday. It feels tangible, like something we can achieve in the next few chapters of our story. What will it be like when we finally arrive on Mars? We can envision the scene. A crew of explorers will descend in a lander, their hearts pounding with excitement and caution as they peer out at a landscape no human has ever seen in person. The hatch will open, and as they climb down a ladder, they'll see a sky tinted butterscotch pink by dust, and a sun that's just a bit smaller and dimmer than the one we know on Earth. One of them will step onto the rusty soil, and, like Armstrong did on the moon, say perhaps a few historic words. Their boots will leave the first human prints in the reddish sand. Above them, the lander's hull gleams in the alien daylight, and on a nearby ridge, maybe the solar panels of a robotic rover glint. An earlier emissary that scouted this landing site for them. Those first pioneers on Mars will face an environment even more hostile than the moon. The air is a thin whisper of carbon dioxide, unbreathable, and only about 1% as thick as Earth's. The temperature swings wildly and often stays well below freezing. So the astronauts will live in habitats they bring or build, likely sturdy tents or modules with thick walls, possibly even covered in Martian soil to block radiation. Inside these living quarters, they'll have the comforts of shirt-sleeve air, warm lights, and communication links with Earth, though every exchange will have minutes of delay. They will set up life support systems to generate water and oxygen, perhaps by melting ice from beneath the soil and splitting it into hydrogen and oxygen. They might grow some hardy plants in hydroponic greenhouses, adding fresh vegetables to their diet of packaged foods. For power, they could deploy large solar arrays on the Martian surface, or a small nuclear reactor for the necessary continuous energy. Exploration on Mars will be both familiar and entirely new. Like Apollo astronauts, the crew will venture out in pressurized suits to collect rocks and search for evidence of past water or life. But unlike the short moon excursions, Mars explorers could stay for months, traversing the landscape in pressurized rovers that allow them to travel many miles from their base. They might visit the edge of a deep canyon or drill into the ground to see what lies beneath. Over time, as they become more comfortable, they'll likely set up additional structures, a science lab here, a storage shelter there, slowly turning their landing site into a fledgling outpost. They'll give names to hills and craters around them, turning abstract map features into part of their lived experience. And each night, when they return to their habitat and remove their helmets, there'll be a few friends gathered far from home, looking out a small window at a sky where Earth is just a bright star among many. Beyond the Moon and Mars, the solar system holds other wonders that fire our imagination. We've learned so much from our robotic probes. We know there are icy moons around Jupiter and Saturn that conceal oceans beneath their crusts, places like Europa and Enceladus that might harbour life in their dark seas. We've seen the spectacular rings of Saturn up close and the volcanoes erupting on Jupiter's moon Io. We've traced the lonely orbits of dwarf planets like Pluto on the fringe of the Sun's realm. For now, these are destinations only for our machines, but some dream of one day sending human expeditions to venture further out. Perhaps a research base on a moon of Jupiter, or a daring journey to sail the hydrocarbon lakes of Titan, could be in the cards for far future generations. There's even talk of resource mining in space, missions to asteroids to extract metals and water that are scarce on Earth. If humanity continues to expand its presence, the asteroid belt could become a wild frontier of its own, with prospectors and scientists alike hopping from rock to rock. Even the stars, those constant points of light, have entered our dialogue in a new way. In recent years, astronomers have discovered thousands of planets orbiting other stars. Exoplanets that range from gigantic gas giants to rocky worlds, not so different from Earth. We now know the Milky Way is teeming with planets, and quite a few reside in that comfortable, habitable zone around their stars where liquid water could exist. This realization has raised one of the most profound questions. Could there be life, even intelligent life, on some of those distant worlds? We don't have an answer yet, but the possibility has shifted how we see ourselves. If we are not alone, then the adventure of reaching the stars carries the prospect not just of exploration, but of meeting other beings, or at least finding their traces. And if it turns out we are alone, that makes our duty to cherish and spread life even greater. Interstellar travel, sending a craft to another star, is far beyond our current capabilities, but it hasn't stopped us from thinking about it. The distances are staggering. The nearest star system, Alpha Centauri, is over 4 light-years away, about 25 trillion miles. With today's fastest rockets, a trip there would take tens of thousands of years. Yet scientists have proposed bold ideas, like using powerful lasers to push ultralight sails to a significant fraction of light speed, or harnessing nuclear fusion energy for propulsion. A project called Breakthrough Starshot aims to send tiny chip-sized probes to Alpha Centauri using laser-driven sails, potentially reaching the star in a couple of decades. These would only be machines, not crewed vessels, but it's a step toward bridging interstellar space. And if we imagine human voyages, some have floated the concept of generation ships, where a spacecraft becomes a self-contained world that travels for centuries, with multiple generations living and dying aboard until their descendants finally arrive at a new sun. Such ideas remain speculative and face countless challenges, yet they inspire us to consider the farthest edges of our destiny. They serve as a reminder that exploration has no fixed endpoint. There is always another horizon, even if that horizon glimmers light years away. For now, our immediate focus is on the promising horizons within reach. In the coming years, we will likely see humanity return to the moon with new eyes and new tools. Plans like the International Artemis program envision astronauts walking on lunar soil again, including the first woman and the first person of color on the moon, and perhaps establishing the first semi-permanent lunar encampment. We will test technologies on the moon that could be vital for Mars: habitats, rovers, and resource extraction methods. Not long after, if all goes well, the first crews will be strapped in for the voyage to Mars, ready to become the first Martians, as science fiction author Ray Bradbury once poetically called future human settlers. Their success would mark a turning point in history, a multi-planet civilization. We're also entering a time when space is not only the domain of governments. Private companies have already sent tourists on short trips to experience a few minutes of weightlessness and see the curvature of Earth. Others are developing spacecraft to take paying customers into orbit or around the moon. It's possible that in a couple of decades, visiting an orbital hotel or taking a sightseeing trip around the moon might be available to those who are not career astronauts. The vehicles being built, reusable rockets that land back on Earth, space capsules with sleek designs, are reducing the cost of reaching orbit. If the trend continues, space travel may gradually shift from a rare event to something many people can aspire to in their lifetimes. We may see scientists setting up private research stations in orbit, or filmmakers creating movies on location in space, or even families visiting a lunar habitat once it's established. Standing here in the present and looking ahead, we see a rich tapestry of possibilities. We can imagine children today growing up to live on Mars, describing to their grandchildren how blue sunsets on the red planet looked. We can picture shining cities in orbit, rotating habitats where generations might be born under an artificial sky, yet still gaze at the real stars through vast windows. We can foresee exploration ships venturing into the outer solar system, crewed perhaps by international teams, or even by humans working alongside advanced AI companions. These visions vary in how and when they might come to pass, but they all share the same root: the drive to explore and to expand the presence of life beyond Earth. All these dreams and plans are grounded in something fundamentally human. We have always been a restless, curious species, never content to stay in one place. The same urge that led ancient Polynesians to paddle into the open Pacific, not knowing what lay beyond the horizon, is at work even now, as we build starships in our minds. Exploring space is in many ways an expression of our deepest longings, our desire to know what lies beyond the next hill or across the cosmic ocean, our need to answer big questions about our origins and our uniqueness, and our hope that in doing so, we might become more than we were before. As we plan these future journeys, we also find ourselves reflecting on how venturing into space is changing our perspective on everything. We've seen Earth from afar and learned about planets near and far, and that knowledge gently reshapes how we see ourselves. We recognize that our planet is precious, that life is fragile, and that we as a species are capable of great things when we work together. Each successful mission, each new footprint on an unknown surface, stands on the shoulders of thousands of contributors and centuries of knowledge. In that sense, our push outward has been a grand unifying endeavor, one that transcends borders and generations. And so, with our eyes on the horizon, we carry forward the dreams of those who came before. The universe around us is vast and silent, but it beckons with possibilities. We have learned to fly, to escape our cradle, to live in orbit, and to even walk on another world. Yet in cosmic terms, we are still at the dawn of our spacefaring age. New chapters of this Odyssey await, filled with challenges and wonders we can only dimly imagine. All the while, the stars will continue to shine above, as they have for eons, waiting for us to arrive. With calm determination and a sense of collective purpose, we will step out further into that infinite night. Our journey continues, and the cosmos awaits. Far above the sleeping Earth, a silent home circles the planet. In the darkness of space, an orbital haven drifts gracefully, full of gentle light and human presence. This is a space station, a sanctuary where the familiar and the extraordinary meet. Inside, astronauts float through narrow corridors as Earth glides by below. Through wide windows, they watch blue oceans and white clouds passing beneath them. A breathtaking view that never quite feels real. In this peaceful frontier outpost, life unfolds in a slow, deliberate rhythm, far removed from the rush of the world spinning silently below. Everything is calm, weightless, and slightly mysterious in this haven above the atmosphere. For over 2 decades now, humans have lived continuously in low Earth orbit. The International Space Station has been occupied since the year 2000, a testament to our ability to survive beyond our home planet. Its crew members come from many countries, sharing sunrises and experiments in microgravity as a common experience. Every day, the station races around Earth, completing an orbit every 90 minutes. This means the people on board witness 16 sunrises and 16 sunsets each day, as golden light and shadow constantly sweep across their view. In quiet moments, Astronauts often gather by a window to gaze at the gentle arc of Earth, feeling both awe and a deep sense of calm as they drift above their home world. Life on a space station is a study in contrasts. There is the extraordinary setting of endless space outside and the ordinary routines of living inside. Astronauts wake up in sleeping bags tethered to the wall, drifting in dreams as they sleep weightless. They begin their day with breakfast floating beside them, perhaps a warm pouch of coffee and a bowl of oatmeal eaten with a spoon that sticks with surface tension. Simple tasks require new thinking. Water forms into floating droplets, and tools must be carefully secured lest they drift away. Yet the crew adapts, turning weightlessness into a way of life. They laugh as they somersault down the modules, and they learn to be patient and precise in every movement. Each action is gentle and deliberate, as if part of a slow-motion dance. Adjusting to life in microgravity is itself an adventure. In the first day or two, newcomers to orbit often feel a bit disoriented, as their inner ears and brains try to make sense of a world with no up or down. Fluids shift to the head without gravity pulling them down, so astronauts' faces can become puffy and their sense of smell changes, like having a mild cold. There can be bouts of space sickness as the body recalibrates. But this phase passes, and soon they learn to move with slow, intentional motions, pushing off gently to float from one end of the station to the other. They start to delight in the freedom of weightlessness, the ability to effortlessly flip upside down or glide through a hatchway. At night, they no longer lie down to sleep, but drift in soft sleeping bags secured to the wall. They awaken without the aches of a mattress, their bodies unburdened by weight. They also maintain routines to keep themselves healthy. A couple of hours of exercise each day to counteract the muscle and bone loss that weightlessness can cause. On a treadmill strapped in place, or a stationary bicycle bolted to the floor, they sweat and pedal in midair to stay strong. Over time, their bodies adjust and they find a new normal in orbit. What once felt strange, like drinking from a floating bubble of water or seeing a crewmate working upside down on the ceiling, becomes second nature. In floating, they rediscover a childlike sense of play and adaptability. It's a testament to human resilience that even in this most unusual environment, life can feel routine and comfortable after a while. During the workday, experiments and maintenance keep the crew busy. An astronaut might tend to a small garden of lettuce and flowers growing under LED lamps, observing how plants develop without gravity's pull. Others might conduct experiments on how fluids behave in microgravity, or how metal alloys solidify differently when not influenced by weight. Flames burn in curious spherical shapes in a microgravity experiment chamber, teaching us about fire in space. When something breaks, the crew carefully retrieves their tools, often velcroed to the walls, and works together to fix equipment or install new components. Scheduled exercise sessions come and go, where astronauts tether themselves to a machine to run or lift weights in the form of resistance devices to keep their bodies strong. Through it all, there is a sense of calm focus. The only sounds are the gentle hum of life support fans and the occasional laughter or soft conversation among crewmates. In the evenings, the crew shares a meal, gathered around a small table in the galley. They squeeze tiny droplets of sauce onto their rehydrated meals and talk about the day's work. Through the window, city lights sparkle on the night side of Earth far below. For a moment, everyone pauses to float at the cupola window, watching lightning storms dance in the clouds, or the green glow of an aurora spreading over the polar atmosphere. These moments remind them how connected they still are to the Earth they left behind. Even during their personal time, An astronaut might float quietly by a window, listening to favorite music, or simply soaking in the view. With the world silently turning below and stars sharp against the blackness, they often feel a profound peace. The sight of a sunrise bursting over Earth's curve, or the gentle flicker of distant thunderstorms, reminds them that home is still close, even in the silent void. Many astronauts describe a deep sense of unity and wonder in these moments. From this vantage, Earth appears as one borderless oasis of life, beautiful, fragile, and whole against the infinite dark. In the solitude of orbit, they feel the presence of home in every golden dawn, and in each familiar voice that reaches them via radio from across the emptiness. Stepping outside the station for a spacewalk is perhaps the most otherworldly experience of all. When an astronaut ventures out the airlock, secured by a tether, they find themselves floating in the vacuum with the entire planet visible beneath their feet. In a bulky white suit, they move slowly and carefully, the only sound the soft whisper of their own breathing. The stars around are unblinking pinpoints in a black sky, and the sun's light is blindingly bright without an atmosphere to soften it. As they work to install a new solar panel or tighten a bolt on the station's exterior, they feel a profound stillness. Each movement is measured and deliberate. Hanging in the void, they are both alone and yet accompanied by all of humanity watching over their shoulder. Hours pass in the silent ballet of work, the Earth spinning below, until finally the astronauts guide themselves back to the airlock. When they re-enter the station, they are greeted by colleagues with warm smiles and pats on the helmet. The contrast between the harsh vacuum outside and the safe, pressurized warmth of the station amplifies the coziness of their orbital home. These orbiting habitats have taught us invaluable lessons about living in space. We have learned how to recycle air and water, how to keep a crew healthy and mentally well during long isolation, and how to fix systems when the nearest help is thousands of kilometers away. Perhaps most importantly, we have learned that people from many nations can live and work together peacefully above the Earth, bound by a common quest. The space station is a symbol of unity and a laboratory for the human spirit, proving that even in the most challenging environment, cooperation can thrive. The current station will not last forever, but already plans are underway for new stations to take its place in orbit. Some will be built by private companies in partnership with national space agencies, high-tech outposts that could host not only professional astronauts, but private visitors and researchers from many countries. These future stations will carry on the work of the ISS, ensuring a continuous human presence in orbit for years to come. This cooperative spirit will be crucial as humanity pushes farther outward. As comfortable as we have become in low Earth orbit, our eyes are ever drawn beyond. In the night sky, one light has beckoned us back since the days of Apollo, the moon, glowing softly with a pearlescent grey hue. This familiar companion world orbits Earth as it always has, silently inviting us to return. After decades of absence, humanity is preparing to answer that invitation and journey again across the 250,000 miles of space to reach the lunar surface. But this time, we go not just for brief visits, but with plans to stay and build a foothold on our moon. It has been over half a century since humans last walked on the moon. Those Apollo astronauts left boot prints and flags in the lunar dust, then departed, leaving the moon to silence once more. In the years since, we have often gazed at the moon and dreamed of going back. Now, at last, New rockets and spacecraft are being readied to carry people there again. There is a palpable excitement as this new era of lunar exploration dawns. We imagine the moment when, once more, a human being in a white spacesuit will step down onto that pale grey soil, taking humanity's next giant leap. This time, our approach to the moon is different. No longer will it be a quick visit to plant a flag and collect a few rocks. Now the goal is to establish a lasting presence. Plans are underway to build a lunar base, a permanent outpost where astronauts can live for weeks or months at a time. Such a base will likely rise in the moon's southern polar region, where the sun skims low on the horizon and provides near constant light for solar power, and where deep craters hide ancient ice in perpetual shadow. That ice, frozen for eons in darkness, could be turned into drinking water, breathable oxygen, and even rocket fuel, a precious resource to sustain our explorers far from Earth. Already, robotic missions have been scouting these promising spots. Orbiters have mapped the moon in detail, revealing where sunlight falls and where darkness preserves pockets of ice. Small landers have tested landing technologies on the lunar surface, gathering data to pave the way for astronauts. In laboratories on Earth, engineers design habitats that could withstand the moon's harsh conditions. The frigid, 2-week-long nights, the unfiltered solar radiation and micrometeorite rain, and the fine abrasive dust that clings to every surface. Piece by piece, the groundwork is being laid for living on the moon. In our minds, we can picture this future lunar outpost. Perhaps a cluster of round, silvered habitats will sit nestled near the brim of a crater, their walls covered in layers of moon dust for insulation and radiation protection. Long solar panel arrays will stretch across the surface, soaking up sunlight during the 2-week day. Not far away, a lander might stand upright and silent, having delivered its cargo and crew. Inside the habitats, astronauts move carefully in the moon's low gravity, which is 1/6 of Earth's. They bounce lightly as they walk, never fully feeling the heavy pull they grew up with. They bring some comforts of Earth, a small kitchen, a table to share meals, cozy bunks for sleep. But much is different. Every drop of water is recycled. Outside the window is not blue sky, but the black of space, even at noon. On the horizon, the distant blue marble of Earth hangs suspended, small but radiant. We can imagine a day unfolding at this lunar base. As the sun's rays creep across the grey dust, astronauts inside the habitat wake from their sleep pods and begin their morning. They don their pressurized suits and unseal an airlock to step outside onto the powdery soil. 2 crew members slowly traverse the surface, their boots leaving crisp prints as they head to a row of solar panels to brush off the fine dust that accumulated overnight. Another astronaut drives a small rover to a shadowed crater nearby, collecting a chunk of ancient ice from the perpetual darkness to be later melted into water. Communication antennas swivel toward Earth, and a faint Earthrise casts a blue glow on the horizon, offering comfort. After hours of labor in the bright but gentle sunlight, the crew returns to the habitat for a midday meal. Through a small porthole, they can see the distant Earth hanging in the black sky. They float around their galley table, sharing rehydrated foods and conversation. Though they reside in an alien wilderness, there is a warmth in these routine moments. In the quiet, one of them jokes about craving fresh bread or the sound of rain, simple things of home. They chuckle, feeling a mixture of homesickness and pride. Their camaraderie and daily rituals give a sense of normalcy in this far-off place. Little by little, living on the moon becomes less a daring expedition and more a way of life. The astronauts living on the moon will face challenges unlike any on Earth. They will experience the long quiet of lunar night, where the sun disappears for days on end, leaving the land in near absolute darkness and intense cold. They will venture outside in bulky suits to explore, gather samples, and build infrastructure, each step kicking up little puffs of grey dust that fall back slowly in the weak gravity. Communication with Earth isn't instant. There's a delay of a couple of seconds in each message, reminding them that they truly are on a faraway world. But they are not alone in spirit. Each lunar night, as they look up at the black sky from the moon's surface, they see a comforting sight. Earth, glowing with swirls of blue and white, rising and setting slowly above the barren horizon. It is a lighthouse in the sky, bright, familiar, and reassuring. That distant Earthrise reminds them that home is still there, watching over them from afar. The return to the moon is a global effort. Many countries and companies are collaborating to make it happen, sharing expertise, resources, and dreams. Through programs like NASA's Artemis, space agencies plan a series of missions that will carry both men and women to the lunar surface, including individuals from diverse backgrounds, representing all humanity. The hope is that when people from around the world set foot on the moon this time, they will do so together, not as competitors, but as partners in exploration. A new generation will grow up knowing that humans live on two worlds now, Earth and the moon, and that we did it by working hand in hand. Meanwhile, other nations are also pursuing lunar ambitions. China, for instance, has announced plans to land its astronauts on the moon and build a research station in the 2030s. In one way or another, humanity as a whole is turning back to the moon, a united endeavour, whether through direct cooperation or parallel efforts, all aimed at making the moon part of our extended home among the stars. In establishing a foothold on the moon, we are laying the groundwork for venturing even farther. Living on the moon will teach us how to use local resources, how to shield ourselves from harsh environments, and how to operate far from Earth's immediate help. All these lessons are essential for the next great destination on humanity's horizon, Mars. With confidence built on the moon, we will be ready to set sail across interplanetary space to reach the red planet that has tantalized our imaginations for so long. Mars, the red planet, glows in our night sky as a steady, rust-coloured point of light. For centuries, it has been a symbol of wanderlust and mystery, a neighbouring world that in some ways resembles Earth, yet is so very different. Today, Mars is the clear next step for human explorers. It calls to us from across the void, around 140 million miles away on average. That distance makes reaching Mars far more challenging than reaching the moon. Yet our determination to stand on its ochre plains grows stronger each year. Robotic explorers have been our trailblazers to Mars. We have sent orbiters to map its giant volcanoes and deep valleys, landers to touch its soil, and rovers to wander its deserts. These machines have revealed a world that was once warmer and wetter, a planet that long ago had rivers, lakes, and perhaps even an ocean. The rovers, acting as our mechanical geologists, have found rocks etched by ancient streams and have sniffed the thin, dusty air for clues of past conditions. With each discovery, our excitement grows. We now know Mars holds water ice locked in its polar caps and beneath some soils. We know it has the resources we might need to survive there. And we know that while it is harsh, with dust storms, fierce radiation, and freezing nights, it is a place we can likely endure and someday call home, at least in part. Preparing to send humans to Mars is a monumental task. Unlike a trip to the moon, which takes a few days, a journey to Mars is measured in months. Astronauts will spend 6 to 9 months in transit, travelling tens of millions of kilometres through deep space. During that time, they will live in a cramped spacecraft, relying on life support systems to provide air, water, and protection from radiation. They will watch Earth shrink to a pale blue dot behind them as they drift through the vast darkness en route to a new world. A Mars mission demands careful planning, not just for the voyage out, but for living on Mars and the journey home. Once a crew lands on Mars, they cannot simply turn around and leave. They must wait many months for Earth and Mars to align properly for the return trajectory. This means the first people on Mars will likely stay on the Martian surface for over a year. They must be prepared for an extended adventure, a long outward journey, a prolonged residence on another world, and then another long trip back to Earth. It will be an unprecedented test of endurance and self-reliance. How will they survive and live during that time on Mars? This question drives much of our preparation. Plans call for sending habitats and supplies ahead of the crew so that a base is ready and waiting when astronauts arrive. Inside these pre-positioned habitats, life support systems will generate breathable air, likely by pulling oxygen from Mars's carbon dioxide atmosphere, and recycle water in closed loops. Energy will come from solar panels spread out on the Martian soil, and possibly from small nuclear reactors, to provide steady power through the cold nights and dust storms. The astronauts will grow some of their food in miniature greenhouses, tending hardy plants under LED lights to supplement their packaged diet and provide a welcome touch of green life. Mars itself will provide some of the resources needed. The soil, regolith, contains water in the form of ice and hydrated minerals. By heating or processing this soil, explorers could extract water to drink or break it down into hydrogen and oxygen for rocket fuel. The thin Martian air, though not breathable, can be a source of oxygen through chemical processes, demonstrated already by a small experimental device that converted Martian CO2 into oxygen for the first time. In the future, greenhouse domes might dot the outpost, where vegetables grow under the alien sun, and the plants not only feed the crew, but help refresh their air. These innovations will allow the explorers to live off the land, at least in part, making their mission more sustainable. There is also the question of shelter and safety. Mars has a very thin atmosphere, offering little protection from solar radiation or micrometeoroids. It's cold, with temperatures plummeting far below freezing each night. To live there, astronauts might build their shelters partly underground or shield them with thick layers of Martian soil. Some plans suggest inflating habitat modules and then covering them with regolith using robots, creating an earthen blanket to protect those inside. Over time, a base on Mars could grow from a small landing habitat into a more complex village. Connected modules where the crew can work in laboratories, maintain vehicles, and relax in a common area with a window looking out on the rusty landscape. Bit by bit, what begins as a campsite could evolve into humanity's first off-world settlement. Even before setting foot on Mars, astronauts train extensively on Earth to prepare for the Martian environment. In recent years, small teams have spent months in long-duration simulations of Mars missions here on Earth. They live in isolated habitats built in remote deserts or volcanic landscapes that resemble Mars's terrain and barrenness. Inside these Mars analog habitats, crews practice surviving with limited resources, recycling water and air, growing a tiny indoor garden of leafy greens, and coping with confinement in a small space. Communication with the outside world is time delayed by many minutes to simulate the distance to Mars, and whenever the team steps outside, they must wear mock spacesuits. Inside these simulations, every routine mimics Mars. They might drive a rover across a sandy plain in a Utah desert or a Hawaiian lava field, never venturing out without a suit. These experiments, whether on the slopes of Mauna Loa or the Arctic tundra, give valuable insight into the psychological and logistical challenges of a Mars mission. By rehearsing life on Mars here on Earth, we learn lessons in advance, lessons in teamwork, problem-solving, and self-sufficiency that could make all the difference when the real mission unfolds on the red planet. What will it be like when humans finally stand on Mars for the first time? We can imagine that moment. A silver-white lander descends on a column of flame, kicking up red dust as it settles onto a broad Martian plain. After the dust cloud dissipates, the hatch opens, and the astronauts inside take their first steps down the ladder onto alien ground. They feel the unfamiliar tug of Mars's gravity, about 1/3 of Earth's pull. It's lighter than what they knew on Earth, yet heavier than the weightlessness they've grown used to during their long journey. Walking in this gravity will feel strange at first, but manageable. They look around at a horizon that extends farther than on the moon, under a salmon-coloured sky. Perhaps the sun is low on the horizon, casting a golden hue through the dusty air, and 2 small moons, Phobos and Deimos, might already be visible in the twilight, appearing as swift-moving stars overhead. That first human footprint on Mars will mark a profound milestone. In that instant, 2 planets will share human inhabitants. Those explorers will carry with them the adventurous spirit of all who came before. As they begin their work, setting up instruments, collecting the first samples of Martian soil to return to Earth, and unfurling a flag, or perhaps a commemorative plaque, they know they are making history. They conduct experiments on the reddish soil, scoop up bits of rock that may hold secrets of Mars's ancient past, and set up life support equipment for their habitat. They are pioneers in the truest sense, figuring out how humans can live on a world that is both like and unlike our own. Each day on Mars brings new discoveries. Clad in their protective suits, the astronauts venture out from the habitat to explore the ruddy landscape around them. 2 crew members might climb into a pressurized rover and drive across the cold desert toward an ancient riverbed that once flowed with water ages ago. They rumble over plains of red dust and jagged rocks until they reach the edge of a dried lake bed where layered sediments lie exposed, evidence of water long ago. Parking the rover, they step out onto the powdery ground and collect samples of the exposed layers of clay and stone, knowing these pieces of Mars hold clues to a time when the planet was warmer and wetter. Using a drill, they take a core from the soil, carefully storing it to later analyze for any hints that microscopic life might have existed in Mars's distant past. As they work, the thin air and silent landscape underscore the feeling of being truly on an alien world. Yet, as their boot prints join those left by the rovers that preceded them, the astronauts feel connected to a grand scientific quest. With each excursion, they push a little farther from their base, mapping the land, scaling small hills, peering into craters, learning Mars's secrets step by step, and extending the reach of humanity on this new frontier. We can envision them climbing a rise at the end of a long day's work to watch the sun sink below a distant crater rim. The sky fades to butterscotch and purple, and the tiny moons of Mars appear, racing quickly across the twilight. In this quiet moment, the crew members know they are the only people on this entire planet. Later, back inside their habitat, the astronauts gather for dinner. Perhaps part of the meal is a fresh salad of leafy greens they've grown in a small greenhouse, the first Martian produce. They sit around a small table, sharing rehydrated food warmed on their galley, and exchange light-hearted stories of the day's adventures. Through a little round window above them, they can see Earth, now just a bright star among countless stars in the night sky. How extraordinary to realize that tiny star is our home, containing everyone else we left behind. Yet here they are on Mars, so very far away. proving that we can extend life to another world. Even as we prepare for journeys to Mars, we also set our sights on other destinations that orbit the Sun alongside the planets. Scattered throughout the solar system are countless asteroids, small worlds of rock and metal, remnants of the early formation of our system. These asteroids are more than scientific curiosities. They may hold the keys to living and traveling in space sustainably. In their ancient craters and veins lie resources that could help fuel and feed future explorers. And so, humanity turns its attention to these wandering stones, seeking to unlock both their secrets and their usefulness. Asteroids come in many shapes and sizes. Some are tumbling mountains of rock hundreds of kilometers across, with enough gravity to pull themselves into rough spheres. Others are tiny boulders that could fit in a living room. Most asteroids reside in the broad asteroid belt between Mars and Jupiter, but many stray much closer, even passing near Earth. These near-Earth asteroids are particularly interesting because one day they might be visited by our spacecraft, perhaps even by astronauts. Imagine a space explorer floating next to a dark, carbon-rich asteroid only a few hundred meters wide, with the vast emptiness of space all around. It would be a surreal landscape, not a planet or a moon beneath their feet, but a miniature worldlet, an island of rock in the void. Why are we interested in asteroids? One reason is scientific. They are time capsules from the birth of the solar system, holding clues about how the planets formed, and perhaps how the ingredients for life reached Earth. But another reason is practical. Asteroids are rich in materials that could be extremely useful. Some are packed with metals like iron, nickel, and platinum, the raw materials for building and industry. Others contain water frozen into minerals, or as ice in shadowed craters. Water is as valuable as gold in space. It can be turned into drinking water, oxygen to breathe, or split into hydrogen and oxygen for rocket fuel. On Earth, such resources must be mined and lifted at great cost into space. But if we could harvest them from asteroids, it would revolutionize our ability to live and work off Earth. The idea of mining asteroids has moved from the pages of science fiction towards serious study. Engineers and entrepreneurs have proposed missions to test extracting resources from these minor worlds. We can imagine robotic spacecraft rendezvousing with a small asteroid and anchoring to its surface with gentle harpoons or screws to avoid drifting off in the weak gravity. Such a probe might deploy drills to bore into the rock, or ovens to heat samples and extract water vapor from the minerals. The collected ice could then be melted into water and split into hydrogen and oxygen, effectively creating fuel and air. In essence, an asteroid could serve as a cosmic refueling station, a place where future spacecraft on long voyages stop to top up their tanks. Such scenarios are still mostly conceptual, but the potential is extraordinary. A few private companies have even launched small prospecting satellites to scout near-Earth asteroids, hoping to be the first to tap these resources. Space agencies too have taken important steps. NASA's OSIRIS-REx mission, for example, travelled to a near-Earth asteroid named Bennu, collected a sample of its material, and brought it back to Earth, giving us a precious glimpse of what asteroids hold. Similarly, Japan's Hayabusa 2 mission returned samples from the asteroid Ryugu, revealing organic compounds and water-bearing minerals. These bits of space rock show that the building blocks of water and even the precursors to life's chemistry are present on these wandering objects. If we scale up such efforts, one day we might routinely send miners, robotic or even human, to extract what is needed from an asteroid instead of hauling everything from Earth. The vision of asteroid mining also includes moving resources to where they're needed. Perhaps in the future, we might capture a small asteroid and gently guide it into orbit around the Moon or Earth, creating a stockpile of materials within easy reach. Concepts like this sound bold, but they mark a shift in how we think about space. Not as an empty void where we must carry everything, but as an environment rich with materials we can use. By living off the land, even the land of a tiny airless rock, we make long-term exploration more feasible and sustainable. Eventually, humans themselves may venture to an asteroid to prospect and work. Such a mission would be unlike any before. In the negligible gravity, astronauts would need to tether themselves or use handheld jetpacks to navigate around the floating terrain. Picture a crew arriving at a tumbling mountain of rock only a few hundred meters across. They secure their spacecraft to its surface and step out, their movements slow and careful to avoid drifting away. Once outside, they might anchor safety lines and move about the asteroid's surface, which is so small that a strong jump could send them sailing off into space. Using specialized tools, they drill into the rock to extract core samples and deploy automated machines that sift through the asteroid's soil for valuable metals or ice. The sun's light is harsh and unfiltered out here, and the black sky is filled with 1 billion stars even at noon. In the distance, Earth would be just a tiny blue spark. For these astronaut miners, the experience would be both an expedition and a job, exploring an alien world while beginning to use its resources. It would mark a new chapter in exploration, not just visiting worlds, but utilizing them to support further journeys. As we contemplate harvesting asteroids, we also continue to explore them for pure discovery. Each asteroid visited is a world unto itself. Some even have their own tiny moons, while others are loose rubble piles barely held together by gravity. By sending missions to these space rocks, humans gain practice navigating novel gravitational environments and operating far from Earth. Each experience is a stepping stone, building confidence and capability. And they spark imagination. Standing on an asteroid and looking up, one would see the sun as a blindingly bright star, and Earth perhaps as a tiny point of light, reminding us how far we have come, and how precious our home planet is, even seen from such a great distance. To traverse the vast distances between these worlds, we must also reinvent how we travel. All our ambitions, living on the moon, journeying to Mars, mining asteroids, ultimately depend on the ships that carry us. Space is enormous, and the faster and more efficiently we can cross it, the more of it opens to us. For over half a century, chemical rockets have been our workhorses, lifting us into orbit and beyond. Engineers are pushing these rockets to their limits by building them ever larger and more efficient, even aiming to make them fully and rapidly reusable. One example is a next-generation spacecraft called Starship. If successful, this towering rocket will be able to ferry dozens of people or tons of cargo into space in a single launch and then land back on Earth to be used again. Such a capability promises to dramatically lower the cost of reaching orbit and beyond. Yet even these cutting-edge rockets face the fundamental limits of chemical propellant. To truly sail the cosmic seas and shrink the travel times between planets, we are developing new methods of propulsion. Some already being tested, others still in the realm of theory and dreams. One promising technology already in use is electric propulsion, particularly ion drives. Unlike a traditional rocket that burns tons of fuel in a roaring blaze for a few minutes, an ion drive works with patient, continuous thrust. It uses electricity, often from solar panels, to ionize a gas like xenon and expel those ions out the back of the spacecraft at extremely high speed. The force produced is tiny, akin to the weight of a feather resting on your hand. But in the vacuum of space, without air resistance or gravity to slow it down, that gentle push can go on for months or years. steadily accelerating a craft to tremendous speeds. Ion engines have already powered probes on impressively long journeys, even visiting multiple asteroids in one trip. Feats that would have been very difficult with conventional propulsion limited by fuel mass. These engines emit a beautiful faint blue glow as charged particles stream out, quietly propelling their craft. Watching an ion thruster in operation, one might liken it to a small, steady star shining at the back of a spacecraft, pushing it onward ever so gently. Another innovation on the horizon is the use of nuclear power for propulsion. One approach, under development again now, is the nuclear thermal rocket. In this design, a compact nuclear reactor aboard the ship would heat a propellant, like liquid hydrogen, to extreme temperatures, then funnel it through a nozzle to produce thrust. This concept was tested on the ground decades ago and is now being revived for future missions. A nuclear thermal rocket could potentially offer twice or more the efficiency of the best chemical rockets. In practical terms, that means it could shorten a journey to Mars considerably or carry a much heavier payload for the same fuel. Imagine a sturdy spacecraft with a glowing reactor core firing a translucent plume of heated hydrogen gas. The exhaust might be almost invisible, yet incredibly potent, cutting a voyage of many months down to perhaps only a few. Shorter travel times would reduce the time astronauts spend exposed to cosmic radiation and microgravity, making deep space missions safer and more feasible. Even more advanced propulsion concepts are being explored as well. Plasma-based engines, for example, use electromagnetic fields to accelerate propellant to extreme speeds. One design, known as VASIM-R, Variable Specific Impulse Magnetoplasma Rocket, would heat a gas into plasma and hurl it out the back with magnetic fields, potentially providing higher thrust than current ion drives, while still being far more efficient than chemical rockets. If powered by a strong energy source, perhaps a nuclear reactor, a plasma rocket like this could further cut the travel time to Mars. Some estimates suggest it could reduce a trip to mere weeks instead of many months. Looking farther into the future, scientists dream of propulsion systems that tap into the same energy that lights the stars. Fusion. A fusion rocket would fuse light atoms together to release enormous energy, like a miniature star engine. In theory, a fusion-powered spacecraft could achieve velocities that make today's rockets look slow, perhaps allowing us to reach the outer planets in a fraction of the time, or even begin to approach a few % of light speed for interstellar precursor missions. Such technology remains speculative. Sustaining fusion in a controlled way is an unsolved challenge, even for power plants on Earth. Yet research continues, because the promise is so great. If we crack the fusion drive, journeys to distant worlds could shorten from years to months or weeks, truly opening up the cosmos to human travel. Each new propulsion breakthrough transforms what was once impossible into the possible. As space travel becomes faster, safer, and more routine, it also becomes more accessible. No longer will space be the exclusive realm of a few specially trained astronauts on government missions. A new era is dawning, one in which many more humans can experience the wonder of space firsthand. We stand at the threshold of space becoming not just a destination for scientific exploration, but a place where ordinary people can travel, work, and even play. This is the dawn of space tourism and a burgeoning space economy, the moment when space truly becomes a domain for everyone. Not long ago, the idea of vacationing in space belonged purely to science fiction and fantasy. But in recent years, we've seen the first glimmers of space tourism becoming reality. Private companies have developed spacecraft capable of carrying paying passengers, and a handful of adventurous civilians have already taken trips beyond the atmosphere. Some have soared on brief hops just to the edge of space, experiencing a few minutes of weightlessness and gazing at the gentle curve of Earth against the black backdrop before returning to the ground. Others have gone further, spending several days orbiting the planet in a private spacecraft, circling Earth every 90 minutes like the astronauts before them, and peering out the window at the panorama of our world from above. This new era has been enabled by the advent of private spaceflight companies developing reusable rockets and modern crew capsules. 2 decades ago, a few adventurous individuals managed to visit the International Space Station by buying seats on Russian rockets, rare and expensive trips. Now, private missions designed for civilian crews are becoming reality. In one notable instance, a crew of 4 ordinary citizens, with intensive training but no prior astronaut experience, orbited Earth for 3 days in a SpaceX Dragon capsule. They launched atop a Falcon rocket, spent days floating in microgravity, conducting experiments and admiring the view, and safely returned home. Their successful journey proved that one doesn't need to be a career astronaut to venture into orbit and live in space, even if only for a short while. Ambitious plans are quickly unfolding. One private venture, led by a Japanese entrepreneur, is preparing to send a group of artists and dreamers on a journey around the moon. They would retrace the path first taken by Apollo 8, looping around our lunar neighbor and back, but this time as private explorers. If this mission, aptly named Dear Moon, proceeds, those travelers will become the first humans to travel to the moon since the Apollo era. And they'll do so not as national representatives in a space race, but as a privately organized crew sharing their experience through art and media. Their goal is to inspire the world with what they see and feel as they swing behind the moon and witness Earth rising beyond it. Closer to Earth, short suborbital flights have also begun carrying passengers to the threshold of space. On these trips, a rocket-powered vehicle, like Blue Origin's New Shepard capsule or Virgin Galactic's winged spaceplane, boosts its riders up above the atmosphere to where the sky turns black and the curvature of Earth is clearly visible. For a few thrilling minutes, the passengers unstrap and float freely around the cabin, somersaulting in zero gravity and pressing their faces to the windows to soak in the breathtaking sight. They see the thin, luminous band of Earth's atmosphere hugging the planet and the vast darkness beyond. Before long, gravity pulls the ship back down, and they settle into their seats as the capsule or spaceplane re-enters the thicker air and glides or parachutes back to Earth. Nearly everyone who has experienced this has described it as life-changing. Seeing Earth as a fragile, luminous ball hanging in the void brings a profound sense of connection and responsibility for our home. It's a view once reserved for astronauts, now slowly opening to more eyes. The coming decade may also see privately operated space stations in orbit. Companies are designing habitats that could serve as orbital hotels or research labs for hire. In these future outposts, tourists might book a room with the ultimate view, large windows looking down on Earth's panorama, and spend days experiencing the magic of life in zero gravity. Film crews could visit to shoot scenes with Earth floating outside the window. Meanwhile, scientists and engineers might rent modules to manufacture materials in microgravity, free from the constraints of Earth's gravity. Microgravity offers unique conditions for industry and science. Without the pull of gravity, crystals can grow larger and more perfect. Biological cells can develop in 3 dimensions without settling, and delicate mixtures don't separate. This means certain products and research, from advanced semiconductor crystals to new pharmaceuticals, might be done better in orbit. Companies are already experimenting with making high-quality optical fibers on the space station. In weightlessness, these fibers can form with far fewer imperfections, allowing data to flow through them with less loss. Biomedical researchers are testing the growth of human tissue and organs in space, hoping the microgravity environment will enable structures that can't form properly under gravity's influence. A commercial space station could host these endeavors, proving that commerce and science both have a place in orbit alongside exploration. These developments herald a major shift. Space is starting to become not just a realm for elite astronauts, but a destination that more people can dream of. In the beginning, of course, only the very wealthy or highly sponsored will have the chance to go, much like how in the early days of aviation, only a few could afford to fly. We are still in that exclusive phase of space tourism. Yet as innovation continues and competition increases, costs are likely to come down over time. We can imagine a future where a trip to an orbital station, or even a week-long stay on the moon, becomes safe and almost routine. Perhaps one day, it might even be attainable for ordinary families, after years of savings, or through scholarships and lotteries. In that future vision, the people venturing into space would hail from every corner of the globe. The human presence beyond Earth would grow more diverse, not just military pilots and scientists, but teachers, artists, doctors, students, people of all backgrounds, sharing in the experience of living and working in the cosmos. Each new traveler who sees Earth from above tends to return with a changed perspective. They see our planet floating in the void, without borders, a fragile oasis sustained by a thin veil of atmosphere. This feeling, often called the overview effect, instills a profound sense of unity and appreciation for Earth. If space truly becomes accessible to everyone, imagine the impact. Thousands of people gaining that cosmic perspective. It could foster greater care for our home world and a realization that, despite our differences, we all share something singular and precious. In this way, expanding our presence in space might bring us closer together back on Earth. Space for everyone means the wonders of the cosmos enriching all of humanity, not just a select few. With space gradually opening to humanity, one might wonder, how far can we ultimately go? So far, all of our voyages, whether by astronauts or robotic probes, have been confined to our cosmic neighborhood, the solar system. But when we gaze up on a clear night, we see countless stars sprinkled across the sky, each a distant sun. It is natural to dream of journeying to those stars one day. If the Moon, Mars, and asteroids are the new frontier of the coming decades, then the stars represent a frontier of the far future, a horizon that beckons to our innate curiosity, even if it lies well beyond our present reach. The gulf between our solar system and even the nearest star is almost unimaginable. The closest star system, Alpha Centauri, is about 4.37 light-years away. 1 light-year, the distance light travels in a year, is roughly 9 trillion kilometers. Multiply that by more than 4, and that's the chasm separating us from our stellar neighbors. With our current technology, a probe like Voyager 1, the fastest object we've launched so far, would take over 70 millennia to reach Alpha Centauri. So, reaching another star within a human lifetime remains beyond our grasp at the moment. Yet this very challenge inspires us to push the boundaries of science and engineering even further, refusing to see impossible as permanent. In recent decades, powerful telescopes have revealed that many of those twinkling stars have their own planets. We have detected thousands of these exoplanets, and they come in astonishing variety. Some are gas giants larger than Jupiter, and others are small, rocky worlds that could be similar to Earth. Intriguingly, some of these exoplanets orbit their suns at just the right distance for liquid water, within the so-called habitable zone. In fact, the nearest star to the Sun, Proxima Centauri, has at least one planet, roughly the size of Earth, orbiting in a temperate zone where water could exist. These discoveries make the dream of interstellar travel even more compelling. There are real destinations out there, actual worlds, not just points of light. Perhaps one of them harbours life of its own, or could even become a second home for humans in the far future. Such possibilities fuel our desire to somehow bridge the immense distances and find a way to visit those distant shores. The first steps toward the stars will likely be taken by robotic probes. One ambitious initiative, Breakthrough Starshot, is investigating how to send tiny, ultra-lightweight probes to the Alpha Centauri system at a significant fraction of light speed. The concept is revolutionary. Instead of using a conventional rocket for the whole journey, thousands of powerful lasers on Earth would focus onto a spacecraft no bigger than a microchip attached to a thin light sail. In this concept, when the lasers hit the sail, the probe would be accelerated to perhaps 20% of the speed of light. At such velocity, it could traverse the 4+ light years to Alpha Centauri in only 20 or 30 years, rather than tens of thousands. Once it arrived, it would zip through the star system in a matter of hours, snapping photos and gathering data on any planets as it flew by, and then beam that information back toward Earth. It's an audacious plan, full of challenges. From aiming the lasers accurately over interstellar distances to building electronics that can survive the journey. Yet it marks the beginning of practical thinking about interstellar travel. For the first time, engineers are seriously contemplating how we might send something to another star and get data back within a human generation. Sending tiny probes is one thing. Sending human beings is far more challenging. The obstacles are staggering. A crewed starship would need to be huge or extremely efficient to carry sufficient fuel, life support, and protection for a voyage that could last decades or centuries. Scientists and visionaries have theorized various far future solutions. One idea is the generation ship, an enormous spacecraft that becomes a self-contained world where entire generations of people are born, live, and die during the long journey to another star. Such a vessel might take hundreds or thousands of years to reach its destination, with the descendants of the original crew completing the mission. Another concept is long-duration hibernation or stasis, putting a crew into a deep sleep for most of the trip, slowing their aging, and then waking them upon arrival. Researchers are studying whether suspended animation might one day be possible for humans, as it would greatly ease the psychological and resource challenges of a century-long voyage. These ideas remain speculative, on the edge of science fiction, but they offer a window into how humanity might one day go beyond simply unmanned probes and actually send settlers across the interstellar abyss. Some dream even bigger, imagining ways to break the apparent limits of physics itself. One such concept, popularized by fiction yet taken semi-seriously by some physicists, is the warp drive. This hypothetical technology involves bending space itself around a ship, compressing space in front of the vessel and expanding it behind. In principle, it might allow a spacecraft to effectively travel faster than light without locally breaking the cosmic speed limit by moving space around it. It sounds fantastical, and at the moment it certainly is. It likely requires forms of energy or exotic matter that we have no idea how to create. Still, theoretical work has shown it isn't outright forbidden by physics, just exceedingly difficult given our current understanding. Another far-out possibility is the use of wormholes, theoretical tunnels through spacetime that could connect distant points in the universe like a shortcut. If such wormholes exist and could be stabilized, they might permit near instantaneous jumps between star systems, These ideas of warp drives and wormholes firmly remain in the realm of conjecture today. No experiment has shown they are feasible, yet it's important that we imagine them, because pushing against the limits of what seems possible drives science forward. Many technologies routine now. Airplanes, submarines, rockets were once the fanciful dreams of visionaries. In dreaming about interstellar voyages, we plant seeds for innovations that might one day make the impossible possible. While true interstellar travel remains a dream for the future, humanity has already sent emissaries toward the stars in a humble form. The Voyager 1 and Voyager 2 probes, launched in the late 1970s, have ventured farther from Earth than any other human-made objects in history. They have passed beyond the influence of our Sun, out past the heliosphere, where the solar wind's strength yields to the pressures of deep space, and entered the vast interstellar darkness between the stars. Each carries a golden record bearing the sounds and images of Earth. Greetings in dozens of languages, music from different cultures, the song of whales, a baby's laughter, ocean waves and rain, a friendly message cast into the cosmic ocean for any who might one day find it. These twin voyagers drift silently through the darkness, tiny craft on an endless voyage. They are poignant reminders that even the longest journey begins with a single step, and that a part of us has already ventured into interstellar space, however humbly. For now, our focus remains closer to home, on exploring and settling our own solar system. The work we do building space stations, planting our boots on the moon, sending expeditions to Mars, and prospecting asteroids is not only for immediate discovery, but also preparation for journeys beyond. Every challenge we overcome, learning to grow food in barren soil, creating breathable air in sealed habitats, surviving months of isolation, or traveling for years in deep space, teaches us how to live away from our home planet. Each hard-earned lesson is a stepping stone toward the distant day when we might embark for the stars themselves. Step by step, we are assembling the skills and knowledge that future interstellar travelers will require. Under the endless night sky, as we look up from whatever world we stand on, be it Earth, the Moon, or Mars, the stars above continue to beckon. Our species has always been driven by curiosity and the urge to explore beyond the horizon. Now the horizon is unimaginably farther than ever before, but we carry the same spirit that once led us across uncharted oceans and continents. We venture onward, not because it is easy, but because the mysteries of the cosmos invite us, and because we seek to know what lies beyond the next frontier. Tonight, as we drift on this spacefaring Odyssey, we feel the gentle momentum of humanity's journey outward. Each new mission, each technological leap, each bold dream builds upon the last and carries us a little further. Our Odyssey among the stars has begun with small steps, and it will continue as long as we have the courage to keep exploring. Slowly and patiently, we are extending our presence beyond Earth, moving from our world into the wider cosmos. Perhaps generations from now, people will stand on distant planets we now see only as points of light. Until that day, we continue forward with hope and wonder, united by the shared dream of humanity among the stars on this endless voyage into the universe. Beyond the edge of our familiar planetary neighborhood, the stars have always beckoned. In the stillness of a clear night, they shimmer with ancient light, each a distant sun holding mysteries and possibilities. For as long as we have gazed upward, we have felt a quiet pull toward those stars. They stir something deep within us, a blend of curiosity and yearning, a dream that one day we might journey across the cosmic ocean to touch the shores of other worlds. In ages past, we could only imagine what might lie out there. Poets and scientists alike spun tales of voyagers sailing the endless dark, leaving Earth behind to wander among strange new suns. Under the canvas of the night sky, early humans may have whispered stories by firelight of spirits dancing among the stars. Centuries later, as our knowledge grew, those stories evolved into bold visions of interstellar voyages, laid out in science fiction novels and on silver screens. These dreams, though fantastical, reflected a real human longing to break free from the confines of our solar system and explore the vast expanse beyond. The dream of interstellar travel has persisted through generations. It is a dream born of wonder and necessity. We wonder what landscapes circle alien suns and whether we might find new homes out there. And we feel a quiet necessity as well, the urge to ensure our survival by not keeping all of humanity's hopes on one small world alone. As we advanced from sailing ships crossing terrestrial oceans to rocket ships reaching orbit, each leap made the next dream feel a little more within reach. The moon, then Mars, and the outer planets. Step by step, we moved outward, and all along the stars loomed beyond, silent and tantalizing. Yet the gulf between stars is immense beyond ordinary comprehension. Light itself, the swiftest traveler we know, takes years to journey from one star to the next. Even our nearest stellar neighbour is over 4 light-years away, a distance that would take tens of thousands of years to cross with the fastest spacecraft of the early 21st century. To cross such a span is like an ant trying to crawl across an ocean. We stand on a cosmic shoreline, waves of starlight washing over us, knowing the true voyage will demand far more than anything we have ever built or imagined before. Realizing this, early spacefarers and dreamers confronted a sobering truth. With conventional technology, reaching another star within a human lifetime was nearly impossible. But rather than quench the dream, this reality only inspired new creativity. If a single life was too brief to make the crossing, perhaps we could find another way. Some imagined starships that could travel faster, craft that might somehow cheat the known laws of physics. Visionaries toyed with wild ideas, engines powered by the annihilation of matter and antimatter, or sails pushed by starlight and laser beams, or even warp drives bending space itself. In quiet laboratories and at late-night desks, equations were scribbled and experiments proposed, all seeking a breakthrough that might one day let us slip beyond the bonds of Earth's sun. These efforts showed promise, but also revealed how formidable the challenge truly was. Even the most powerful rockets we could conceive, propelled by nuclear pulses or fusion reactors, would only shave a journey to decades or centuries instead of millennia, and the fanciful notion of faster-than-light travel remained, for now, a theoretical musing, a tantalizing possibility living in the realm of equations and thought experiments. As of now, no known physics can whisk us instantly from star to star. The universe's speed limit remains in place, guarding the stars like a distant horizon we cannot yet reach. And so, our thoughts turn to a humbler, more patient approach. If we cannot reach the stars quickly, then we will take our time. The dream of interstellar travel evolved into a vision of journeys that last for generations. We began to imagine ships that were not merely vehicles, but whole worlds unto themselves, self-contained, traveling ecosystems that could sustain life over centuries. Inside such a starship, people could be born, live out rich lives, and eventually pass away, all while the vessel steadily glides through the interstellar night toward a distant sun. Their children and grandchildren would carry on the mission, like a baton passed forward through time. This idea, at once bold and pragmatic, rekindled hope. It meant that even without miraculous new physics, the path to the stars could lie within our grasp if we had the dedication and patience. We would not need to outrun light. We would instead learn to live en route, turning the journey itself into our home. The stars would not be reached in a single lifetime, but by a chain of many lives linked by a shared purpose. Consider what such an odyssey would mean. A family might board a ship knowing they will never see the destination, that it will be their great-great-grandchildren who finally step onto alien soil. Those early voyagers would see only the blackness between stars outside their windows, but they would also see something else. The growth of a living community, carrying Earth's legacy forward. With each passing year, the ship drifts farther from the sun that humanity once called home. Outside, the constellations slowly distort as perspective changes across light years. Inside, children laugh, learn, and grow old under artificial skies, tending gardens beneath lamps that mimic the sun. The dream of reaching another star becomes not a sprint, but a marathon across generations. It is a test of perseverance, of faith in a future we cannot personally witness. To embark on such a journey, those first explorers must believe profoundly in what lies ahead, enough to sacrifice the comfort of Earth and a life beneath familiar skies so that their descendants might inherit a new world. In many ways, it is a promise to the future, a promise that the long night will end in sunrise over an unknown horizon for those yet unborn. Even as we hold this dream, we prepare in the present day with small steps outward. Robotic probes serve as our pathfinders. Already, we have flung tiny messengers into interstellar space. The Voyager spacecraft, for example, drifting silently with their golden records, have crossed beyond the edges of our solar system, becoming humanity's first emissaries to the space between the stars. They move at mere tens of kilometers per second, and even at that speed, their voyage to another star would outlast human civilizations. Still, they show that we can send something of ourselves outward, a foreshadowing of journeys to come. And in laboratories and research centers, engineers craft new possibilities, like light sails ready to catch the winds of powerful lasers, potentially accelerating small probes to a fraction of light speed. A tiny, wafer-sized craft might one day zip past distant stars within a human lifetime, snapping pictures and sending whispers of data back home across the void. Each technological advance brings a distant star a little closer within reach. All the while, the emotional core of the dream remains, the innate human desire to explore and to find the unknown. This drive carried us across oceans and over new continents long ago, and now it compels us to look at the night sky with longing. What might we find circling those bright pinpoints? Could we ever set foot on solid ground under the light of a different sun? Imagining that moment, a human being standing under the sky of another world, looking up at unfamiliar stars, gives a gentle shiver of awe. It feels almost spiritual, as if by leaving Earth we would come to know ourselves and the cosmos in a profound new way. This dream does more than promise adventure. It also changes how we see ourselves. When we imagine venturing to the stars, suddenly humanity's story seems so much larger. We are no longer bound to one small sphere of rock and water, but are travelers in a vast, vibrant universe. The distances are humbling, but they remind us that we have room to grow, so many places yet to go. It is a quiet reassurance that even if Earth someday grows too small for our aspirations, or too fragile to bear our weight. There are endless horizons where life can continue, where the story can go on. Thus, the dream of interstellar travel persists as a faint but steady light in our collective imagination. Generations have looked up and whispered to the stars, promising that someday we will come. In the silence of space, we sense no objection, only the patience of the universe waiting for us to muster the will and wisdom to venture forth. In that patient silence, we prepare ourselves. We build ever more powerful telescopes to scout the way, peering for inviting worlds orbiting those distant suns. We cultivate technologies that might sustain us far from home. We reflect on the social and ethical questions: how to maintain hope and purpose over centuries in flight, how to carry the richness of human culture across light years without losing who we are. Slowly, carefully, we lay the groundwork for a journey that, once begun, will redefine us forever. When the day finally comes that a starship rises from our planetary cradle and sets course for the unknown, it will carry not just a crew, but the dreams of all humanity. It will be as if all of us are aboard that vessel in spirit, watching our galaxy slowly shift and welcoming the adventure ahead. And as the engines ignite and the ship glides beyond Pluto's orbit into the deep black, we will know that one of humanity's oldest dreams is at last becoming reality. The road to the stars will be open, and we will be on our way across that vast and silent sea. If one listens closely to our collective heart, one can almost hear a distant echo of future celebrations, cheers of success from a generation yet unborn that will one day arrive at a new world. That echo travels back to us through time, whispering encouragement. It tells us the dream is worth any struggle, that the distant lights in the sky are destinations waiting for courageous souls. That imagined celebration strengthens our resolve. The stars may seem forever distant, but with every year that passes, we inch a little closer. Through ingenuity, patience, and unity of purpose, what was once pure fantasy begins to feel inevitable, a matter of when, not if. And so we stand at the threshold of interstellar travel, dream in hand, ready to become a species of many worlds. All the planning, the innovation, the daring is guided by one shining vision, that sometime in the deep future, perhaps many lifetimes from now, the children of Earth will walk beneath alien skies. With that belief warming our hearts, we turn to the practical challenge that makes such voyages possible: the creation of generation ships, those arcs of the void that carry our hopes across the stars. The idea of the generation ship turns the immense journey into a moving homeland. Instead of racing across the stars in one lifetime, we build a world that can carry us slowly but surely to our destination. Inside such a ship, life continues in a steady rhythm, generation after generation. The travelers wake each morning under an artificial sky, perhaps painted with gentle clouds by human hands or projected by clever lighting. They tend gardens that provide their food, recycle water and air in a carefully balanced dance of biology and engineering, and teach their children about the mission and the distant world that awaits beyond the hull. In every sense, the starship becomes a miniature Earth, an island of life sailing between the stars. These interstellar arcs are enormous feats of engineering. One can imagine a cylindrical vessel, miles in length, slowly rotating around its axis. Inside, along the curving inner surface of the cylinder, lies a pastoral landscape. There are fields of green crops and clusters of homes, and clearings where children play. A river might course gently through the ship's interior, collecting into ponds under a fabricated sky. Perhaps a band of light running along the centre, mimicking a sun. Every inch of the ship is designed with purpose, to sustain its community across centuries of travel. Power might come from a small artificial sun at the core, or from fusion reactors humming quietly in the background. Water flows in contained streams and reservoirs, recycled endlessly to nourish crops and quench thirst. It is a fragile balance, an entire ecosystem contained within metal walls. Yet through ingenuity, it can flourish, providing nourishment for body and spirit alike. Life aboard a generation ship is both ordinary and extraordinary. In daily routine, people work, study, celebrate births, and mourn losses, much as humans always have. Families sit down to meals, teachers pass on knowledge, artists create music and stories, perhaps songs about the home their ancestors left, or tales of the world they are journeying toward. The extraordinary part is that all of this unfolds in the void of space, with the infinite night just outside. When someone steps up to a viewing port, they do not see bustling cities or wide oceans. They see a tapestry of stars and darkness. For the generation born far from Earth, those stars are a constant reminder of their purpose. Each pinprick of light outside is a sun, and one of them is the sun of their destination, growing ever so slowly, brighter over the decades. Time moves in a unique way on a generation ship. A voyage may last centuries, even millennia. To those on board, history back on Earth will advance and change beyond recognition. Yet within their self-contained world, time is marked by the cycles of days and years that they themselves define. The ship's calendar might commemorate the launch day as a kind of founding holiday. Generations may count their lineage by who was the first generation that departed Earth, and who will be the landing generation that finally arrives. Children grow up hearing stories of Earth as a distant, almost mythical place, the blue cradle of humanity that they have never seen. They also hear hopes and vivid descriptions of the new planet ahead, gleaned from telescopic data and the dreams of scientists who chose it as our future home. Maintaining purpose across such timescales is a profound human challenge. How do you keep the original mission alive in the hearts of people born a century after the journey began? Part of the answer lies in traditions and education. The mission's goals and the importance of each person's role are taught as soon as children are old enough to understand. Perhaps there are ceremonies where the youngest generation is shown a certain star through the viewport, the star of their new home, and told, that is where your grandchildren will live. Through shared stories and collective memory, the sense of destiny is preserved. The community develops its own culture, music, and art, reflecting the duality of their existence. Rooted in a ship that is their entire world, yet always moving toward a larger world they will someday inherit. Of course, challenges accompany this journey of lifetimes. The ship must be robust against the hazards of space, tiny meteoroids, radiation, the wear of centuries. The crew becomes adept at repairing systems and finding creative solutions with limited resources. Every piece of machinery, every section of the hull is tended carefully, because there is no help coming from outside. The people are both the passengers and the caretakers of their ark. Psychologically, they find strength in community. No one can survive alone on such a voyage, but together they support one another. If conflict arises, they must resolve it, knowing they all share the same fragile vessel and fate. Over time, a deep understanding settles in. Cooperation is not just a virtue, but a requirement for survival. In the quiet, unchanging night of interstellar space, the generation ship carries human life forward like a seed riding on the cosmic wind. The stars outside barely shift in position over a human lifetime, giving an illusion of stillness. Yet the ship steadily makes progress, year by year. Perhaps the travelers chart their journey by the slight brightening of their destination star, or by the rare occasions of passing relatively near a star system along the way. Imagine a moment, decades into the voyage, when the ship coasts through the fringes of a distant solar system. The crew might gather to witness the faint glimmer of alien sunlight, or detect the tug of a planet's gravity, knowing it is not their final stop, but still a notable milestone on their trek. These rare events break the monotony of the voyage and become stories passed down to children. I remember when we sailed past that red dwarf star. Its light tinted our sky for a while, and we knew we were not alone in the universe. As time flows on, the original crew who set off eventually leaves living memory, survived by children and grandchildren who never knew any life but the ship. To them, the idea of open skies and wide oceans exists only in the ship's archives, in pictures and recordings of Earth, or perhaps in virtual reality simulations some used to experience a semblance of Earth's nature. They might tend a small grove of earth trees in the arboretum and smell flowers that once grew in distant soil. These connections to humanity's past remind them of where they come from. Yet they also innovate and adapt. Their language might evolve, their customs shift subtly over the generations. They are still human, but shaped by life aboard a starship, becoming a people in between, belonging neither to Earth behind them nor the new world ahead, at least not yet. Through all these changes, the ship's guiding principle remains constant: deliver its people safely to a new world. After long centuries, perhaps the sensors finally detect the glow of the target star, becoming stronger against the starfield. What was once a point of light, no different from others, gradually becomes a distinct sun, growing day by day in the ship's sky. There is excitement on board, a quiet thrill diffused through the halls. The knowledge that the long journey is entering its final chapter energizes everyone. People revisit the old recordings of Earth's departure and the mission's beginnings, feeling a connection with their ancestors who dreamed this moment would come. The children of the latest generation press their faces to observation windows, trying to spot the first signs of the new solar system ahead. And then comes the day, after lifetimes spent in transit, when the generation ship begins its approach to a distant star's planetary system. Engines that have slept for ages come alive to slow the ship down. The great habitat cylinders, or domes within, are abuzz with preparation for landing. The travellers, who have only known the corridors and gardens of their vessel, now brace themselves to set foot on actual soil that no human has ever touched. There is trepidation, for the unknown awaits, but also overwhelming exhilaration and relief. The voyage across the cosmic sea is nearly complete. As the ship glides into orbit around a new world, many eyes fill with tears. They think of the sacrifices and perseverance of all those who came before on this voyage, many of whom did not live to see this day, yet whose hopes and efforts made it possible. In their memory, the people hold a ceremony aboard the ship, Perhaps there is a moment of silence as they watch the emerald and blue sphere turning below, or whatever colours their new home exhibits. They know that on this day, the human story extends beyond the stars we once knew. Humanity is about to become interstellar in the truest sense, taking root in soil under an alien sky. Landing craft descend, and a new chapter begins. The generation ship's journey culminates in this moment of arrival, but it is not the end of the story, only the close of a long voyage. What lies ahead is the work of building a life on this new world, nurturing it into another home for humanity. With hearts full of hope and eyes open in wonder, the descendants of Earth prepare to take their first steps onto an alien landscape, ready to begin the era of settling distant worlds. On the surface of a distant world beneath an alien sky, humanity finds its new home. The first explorers step out from their landing craft onto strange soil, their footprints pressing into foreign dirt that has never before known the tread of human feet. Above them, a sun similar to our own shines down, but the constellations here are utterly new. Perhaps the air is crisp and breathable, carrying unfamiliar scents on its breeze. For a moment, they simply stand in awe, gazing at the landscape, mountains with a different hue, clouds drifting in novel patterns, maybe the silhouette of two moons rising together. This world was once a mere point of light in our telescopes, given a catalogue number or a hopeful name. Now it is real beneath their boots, solid and welcoming in its own exotic way. The settlers likely carry with them a small piece of earth to this new ground. It could be a vial of soil, a flag, or seeds of earth plants, carefully preserved. In a simple, poignant ceremony, they might plant a young tree grown from Earth's seed into the alien soil, symbolizing the rooting of humanity in its second home. As they water it with recycled water from their ship, they remember the long journey and those who dreamed of this moment. Some gather rocks and samples, marveling at the differences and similarities to our home world. Others set up instruments to test the environment thoroughly, confirming what their starship's data predicted during the voyage. The air is indeed rich enough to breathe, the temperature clement, and the soil capable of supporting life. Each positive result is cause for quiet celebration, proof that the planning and hope were not in vain. In those first days, the pioneers establish a foothold on the new planet. They set up temporary shelters brought from the ship, inflatable habitats or prefabricated modules that unfold into sturdy dwellings. Powered by portable fusion generators or the rays of the new sun captured by solar panels, a little base camp comes to life. Lights glow warmly at dusk under an alien twilight. Inside one dome, a group of settlers share their first meal on solid ground, perhaps savouring crops they grew aboard the ship, or even a few fresh greens planted upon arrival. They find that some earth plants take to the new soil as if it were home, while others need time or tinkering to adapt. Every success, each sprouting seedling, each breath of fresh air, is both a scientific triumph and a spiritual reassurance that humanity can belong here. The challenges of settling a distant world are immense, but these settlers have prepared for generations. They understand the need to work carefully with this planet, to learn its rhythms and quirks. Days might be longer or shorter than on Earth, forcing them to adjust their sleep and work cycles. Gravity could be slightly different, perhaps a bit lighter, making their steps feel springy and their burdens easier, or a bit heavier, turning every task into a new test of endurance. Rain might fall in unfamiliar patterns, and strange auroras could shimmer at night, if the planet's magnetic field dances with stellar winds. The settlers observe and adapt, keeping detailed records like the naturalists of old, knowing they are writing the first chapters of human history on this world. In time, the temporary encampment grows into a permanent settlement. Structures are built using materials at hand: bricks from the local clay-like soil, metals and composites from the ship's stores, even wood from fast-growing earth plants once they take root. The generation ship that delivered them remains in orbit, a relic of the journey that can now serve as an orbital station or be cannibalized for resources. On the ground, new buildings rise that blend Earth engineering with the character of the new world. They construct greenhouses to shelter Earth crops until the outside farms are productive. Water is drawn from local sources, perhaps a clear river or underground springs discovered by prospectors, and purified for drinking. Each step towards self-sufficiency is celebrated. The first loaf of bread baked from flour milled on this planet. The first child born under the light of the alien sun. The first map drawn of their new homeland's contours. As the settlement takes shape, so does a new society. The people carry with them the culture and lessons of Earth, but they are also influenced by their long voyage and this planet's realities. Festivals emerge to mark the anniversary of Arrival Day, or to celebrate the unique seasons of this world. Perhaps on the day when both of the planet's moons hang full in the sky, the colonists gather outside to bask in the double moonlight, creating a tradition their earthbound ancestors never knew. They give their town a name, something aspirational or honoring the dreamers of Earth, and name rivers, hills, and valleys in both familiar and novel ways. Over years and decades, what started as a bare-bones outpost becomes a thriving settlement, with schools to teach the first generation born here, workshops and labs to build and invent, and gardens and parks where children play under a sky that was once alien, but now simply home. Settling a new Earth brings reflections on responsibility. The colonists know they are not just building for themselves, but for all of humanity. They take care to respect this world, to disturb only what they must, and preserve what they can. If the planet has its own forms of life, perhaps simple algae in lakes or hardy lichens on rocks, they study these natives with wonder and caution. To find life thriving independently on another world is a profound discovery, a confirmation that life can emerge beyond Earth. The settlers become its stewards, ensuring that as they plant Earth species and build their homes, they do not needlessly extinguish the life that was already here. In this careful dance, humanity learns not only to take a home among the stars, but to coexist with the new and the unknown. Communication with Earth, if still possible, is a poignant exchange between worlds separated by years. Imagine the messages sent, a transmission beamed toward the old blue planet saying, "We have arrived, humanity lives on," and they would speak the name they've given this new world. Decades later, if and when the message reaches Earth and is understood, there would be celebration as people learn that their far-flung children succeeded. And in return, perhaps a century after landing, a faint reply arrives from Earth with congratulations and news of the human story back home. These conversations, stretching over light years and lifetimes, bind the colony and Earth with a slender, precious thread of shared identity. As the years turn into generations, the new world becomes ever more comfortable for its human inhabitants. The tree planted by the first settlers has grown into a big shaded grove. Fields of alien soil now yield familiar crops, as well as new plants that are hybrids of Earth species and native strains, carefully bred to flourish in the local climate. The colony expands into multiple settlements, spreading out around fertile valleys or along the shores of unfamiliar oceans. What was once a solitary outpost is now a small civilization under a distant sun. And the people, they were once earthlings or ship-borne voyagers, but they have become something else, the first natives of this new Earth. They still know of Earth as the ancestral home, but many have never seen that faraway world except in pictures. Their loyalty and love grow toward the land beneath their feet, its peculiar beauty and challenges shaping a culture distinct from that of Earth. In a few generations, the story of the journey and landing passes into legend. Children hear of the great crossing through the stars and the bravery of the ancestors who made it possible. They walk freely on a planet that once existed only in the wildest dreams of those ancestors, hardly thinking about the vast gulf of space that separates them from humanity's origin. On clear nights, perhaps teachers point out a particular twinkling star on the horizon, dimmer than the rest, and tell the children, "That is the sun, where we all began." The kids might squint and try to imagine a place called Earth, circling that distant point of light, a place they know only from tales. In those moments, the enormity of what has happened sinks in. Humanity is now a multi-world species. The people of this new Earth and those on the old Earth are connected by history, but separated by light years, each thriving under their own skies. The success of one colony fuels the desire to find and settle others. Back on Earth, and perhaps even from the new colony itself as it advances, new missions are planned to reach other promising planets. Over centuries, generation ships, or perhaps faster vessels, if technology has progressed, set sail toward various stars that harbour planets of potential. One by one, distant pinpoints on humanity's star maps become real places with familiar names, new bastions of life. Each world has its own character. One may be ocean-covered with archipelagos where cities float. Another might have rich purple vegetation under a redder sun, giving the sky a permanent twilight hue. Humanity, adaptable and curious, spreads out gently, settling where it can, always learning and changing with each new world. Before long in cosmic terms, there isn't just one new Earth, but many. A handful of neighbouring star systems host human settlements, each a little beacon of our species, shining in the darkness. These colonies trade occasional messages, share knowledge, despite the years or decades the communications require, and perhaps even exchange visitors if advanced ships eventually make interstellar travel swifter. Culturally, they diverge in beautiful ways, each developing its own arts, languages or dialects, and philosophies shaped by the environment and history of its world. And yet, across light years, they all remember their common origin. They all look up at their night skies and know that somewhere out there, other humans are looking up too, under a differently coloured sky, building a life on another world. Settling distant worlds is an act of hope and continuity. It ensures that humanity's flame, if ever dimmed in one place, will continue to glow in another. No single catastrophe can now extinguish the human story, for it is written across multiple planets. With that security comes a broader perspective. People on these new Earths see themselves as part of a grander human journey, one that began on a tiny blue world and is still unfolding. They might even begin to see that humanity is more than one planet's people. It is a network of sister civilizations scattered among the stars, each contributing a verse to a much larger song. From the vantage point of our new Earths, we truly appreciate the rarity and wonder of life. Each successful colony is a testament to cooperation, knowledge, and bravery. Each stands as a guardian of human culture, ensuring that our achievements, values, and dreams carry forward. As these distant homes flourish, they become stepping stones for further exploration. A colony might one day send its own expedition further outward, deeper into the galaxy, continuing the cycle of discovery and settlement. In this way, humanity grows like a spreading tree, branching out from the seed that was Earth, its leaves reaching for the distant sunlight of myriad star systems. The journey to a new Earth, from the first footstep on alien ground to the rise of a thriving society, is a monumental chapter in our Odyssey. It fulfills an ancient longing to find other worlds to call home, to prove that we are not bound to Earth alone. Standing on a faraway hillside, with twin moons above and alien forests below, a traveller might smile and think of Earth fondly, even as they feel pride in how far we've come. Yet as boundless as this accomplishment is, it is not the end of humanity's creativity or ambition. If worlds welcoming enough are scarce, or if we desire to build something even grander, we have the power to create our own habitats in space. The human imagination does not stop at using what nature provides. It extends to shaping new worlds from the raw materials of the cosmos. Thus, even as we cherish the new Earths beneath our feet, our gaze turns to the vast spaces in between, where we might construct wonders, a transition from settling worlds given to us to forging worlds of our own. Building our own worlds in space is the next grand step for an adventurous humanity. Freed from the constraints of planets, we learn that we can create living spaces wherever we choose. Vast habitats spinning in the void, cities drifting under artificial skies. No longer must we search only for planets that nature made. We can craft new havens with our own hands and ingenuity. Out in the darkness between the stars, or orbiting gentle suns, human-made worlds blossom like cosmic gardens, each designed to cradle life as lovingly as any Earth-like planet. The first such habitats might begin relatively small, perhaps as gigantic stations constructed from the metals and minerals of asteroids. Picture an immense cylindrical structure slowly rotating around its axis. Inside, along the curving inner surface of the cylinder, lies a pastoral landscape. There are green fields and clusters of houses. There are even rivers, coursing gently, and small lakes, shimmering under an artificial sky, created by light panels. The rotation of the habitat provides a gentle gravity, pushing everything outward to the cylinder's walls, so that down, for the inhabitants, is literally toward the hull. To someone walking inside, it would feel very much like being in a wide valley that mysteriously curves up at the horizon until it arches overhead. If they look up, toward what is actually the other side of the cylinder, they might see far in the distance the upside-down silhouettes of other towns and forests hanging above, all held in place by spin gravity. Such a place is a world in miniature, complete with weather and day-night cycles, perhaps created by rotating shades or mirrors that let in sunlight from outside, and all the familiar comforts of nature, yet all of it engineered and under human control. As technology and ambition grow, these habitats become larger and more diverse. Some are designed as torus-shaped rings, colossal wheels in space with spokes connecting to a central hub. Others are spheres or domes containing miniature ecosystems. Engineers learn to regulate climate within them, balmy and Earth-like for some, or intentionally different for others. Perhaps a colony prefers a cooler alpine air or a moist jungle habitat. Inside our creations, we are free to tailor each world to our liking, picking and choosing elements of climate and landscape. Imagine a habitat where an entire mountain range has been constructed along one side for recreation, or another where a continuous ocean runs around the interior, allowing for sailing and aquaculture in a ring-shaped sea. With artificial worlds, imagination becomes the only limiting factor. Over time, the scale of our constructs grows truly breathtaking. With sufficient energy and resources, humanity attempts megastructures that were once purely science fiction. One ambitious vision is a Dyson sphere, or more practically, a Dyson swarm, a multitude of habitats and solar collectors arranged around a star, capturing most of its energy output. Instead of living on one tiny planet that receives a fraction of sunlight, we spread out around our sun, and later other suns, building thousands, then millions of independent habitats. Each habitat is a self-contained world, and together they form a glittering swarm that takes on a shell-like shape around the star. From afar, an observer might barely see the star's light, as much of it is being intercepted and used by the swarm. Up close, however, for those living in these habitats, the star hangs in their sky as a brilliant source feeding their solar panels and providing warmth. While nearby in the dark backdrop, they can see the lights of neighbouring habitats like a constellation of artificial stars. Creating such megastructures requires vast engineering prowess and coordination. We become miners of planets and asteroids, carefully dismantling uninhabited moons or rocks to gather building material. We become farmers of sunlight, learning to trap and distribute the enormous energy output of a star. It is a slow, patient endeavour. Assembling a Dyson swarm might take centuries or longer. But in doing so, we unlock a mode of existence that is nearly immortal in its sustainability. With effectively all the energy of a star at our disposal, the potential for growth and innovation is astronomical. Trillions of humans, or whatever we become by then, could live in comfort among the combined habitats, never worrying about exhausting land or resources, for new habitats can always be constructed. Each habitat could be its own culture and experiment. One might house a lush forest and a society living in harmony with dense nature, while another is a high-tech wonder of glittering cities and flying vehicles under an engineered dome. Living in these constructed worlds might change us in subtle ways. Our descendants would know that ground and sky can be manufactured, that rain can be scheduled and seasons adjusted. The concept of a purely natural environment might fade as we exert complete control over our surroundings. This could deepen appreciation for original wild places, like Earth's untouched forests, or lead us to create entirely new ecosystems never seen in nature. Perhaps there will be habitats that emulate alien worlds we discovered, letting people experience what it might be like to stand on the surface of a planet with purple vegetation or under a pale green sun. Other habitats might be artistic expressions, gardens shaped into floating islands, or cities built vertically around the inner curve to create stunning skylines visible from anywhere within. Building our own worlds also teaches us a great deal about sustaining life in all conditions. We become masters of bioengineering, ensuring that plants, animals, and people can thrive in confined, managed spaces. We learn how to recycle everything, every drop of water, every breath of air, so that even in a closed system, life can flourish indefinitely. These lessons circle back to benefit all of humanity, including those on natural planets. With advanced habitat technology, even harsh planets, or the emptiness of space become canvases where we can establish outposts of life. We carry bubbles of Earth with us wherever we go, and then expand them to cover entire settlements, and then entire regions of space. The boundary between what is a world and what is a vehicle or station begins to blur. A sufficiently large habitat, spinning under the light of a sun, is a world for its inhabitants in every practical sense. The difference being that it was designed and built, not born of cosmic accretion. As human-created worlds multiply, humanity's footprint in the galaxy grows not just by colonization of existing planets, but by sheer creation. We may one day fill our home solar system with myriad habitats, adorning the space between planets with life-filled structures gleaming in the sunlight. We might construct huge rings or spheres around other stars where our explorers have gone, especially if those systems lack an Earth-like planet but have abundant materials for building. Each megastructure, from the humble rotating cylinder to a vast Dyson assembly, makes a statement. It declares that intelligent life has taken root here and transformed inert matter into something that lives and thinks. In time, we might transform entire star systems into mega ecosystems of our own making, optimized for the flourishing of consciousness and life. Standing on the inner surface of one of these great structures, a person might look up and see their entire world curving above them, and beyond it, the bright glow of 1,000,000 distant suns. It's a view both cozy and vast, enclosed in a human-made cradle, yet unmistakably in the midst of the cosmos. That sight could bring a profound sense of accomplishment and also humility. We will have learned the artistry of creation at planetary scale, echoing the creative forces of nature. Yet even as we build and build, the stars beyond our constructions continue to shine and beckon. Our artificial worlds are not an end to exploration, but rather a new kind of vessel for it. They could carry us outward, slowly drifting entire communities to other stars over millennia, or serve as way stations for travelers moving between colonies scattered in the galaxy. As we fill space with our works, we cannot help but wonder, are we alone in doing so? If another civilization had built its own megastructures, would we notice? Perhaps one day, as we survey distant stars, we'll find a sun that flickers or dims in a way that's hard to explain naturally, the telltale sign of an alien Dyson swarm or some colossal construct. Likewise, our own engineering feats could become beacons to others. Our habitats, gleaming around a star, might catch the attention of anyone out there looking carefully. In building great structures to sustain ourselves, we may inadvertently announce our presence to the cosmos. This realization leads us gently to another timeless question. We've created homes in the void, and perhaps made ourselves visible across light years. Now our thoughts turn outward once more. If others are out there, other minds, other seekers, might we hear from them? As we gaze at the star-studded expanse beyond our magnificent creations, we listen closely to the cosmic silence, hoping for a whisper from afar. In the midst of our self-made heavens, the yearning to find company in the universe remains, drawing our attention to the faint signals and mysteries emanating from the depths of space. For ages, we have cast our ears and eyes toward the stars, hoping to catch the faintest hint that we are not alone. In the quiet of night, radio dishes stand silently, their vast metal ears pointed skyward to listen to the static and size of the Milky Way. Telescopes, too, gaze at distant planets, searching their thin light for telltale signatures of life. Perhaps an unexpected blend of gases in an alien atmosphere that could only be produced by living creatures, or the flicker of something artificial crossing a star's face. These are the whispers from the cosmos that we seek, subtle, almost inaudible clues amid the vast noise of the universe, clues that somewhere out there life has taken root and might even be reaching out, intentionally or not. At first, our search for alien life was like listening for a pin drop in a hurricane. The cosmos emits a cacophony of natural signals, pulsars blinking like lighthouses, quasars roaring with energy, stars flaring and dimming. Amid this cosmic symphony, we tried to tune in for any pattern or voice that stood out as intentional. Decades ago, scientists began the first projects to scan the radio spectrum for signals that might be more than noise. Early on, there were false alarms and intriguing moments. A sudden spike of radio waves that lasted only minutes, but was so distinct an astronomer scribbled, "Wow," beside the data. A fleeting whisper that spurred endless questions, but was never heard again. Each time an unusual signal was detected, hearts quickened. Could this be it? The cosmic greeting card we've long imagined. Thus far, each has turned out attributable to mundane sources, distant stars, the hiss of atoms, or unnoticed interference from our own technology. The sky, it seems, has been mostly quiet in reply to our calling. Yet the silence does not dampen our hope. If anything, it makes us listen more carefully. With each passing year, our instruments grow more sensitive. We scan more frequencies, more stars, and across a broader spectrum than ever before. We've started looking not just for radio waves, but for optical flashes. Perhaps an alien civilization might use powerful lasers to signal across the void. We watch for odd chemical traces around far-off suns, thinking that the footprint of industry or biology might be detectable across light years. If a planet passes in front of its star, and we catch a hint of its atmospheric makeup, we might discern oxygen, methane, or other gases in proportions that suggest life's presence. In a way, we become cosmic detectives, sifting through faint spectra and delicate signals for any anomaly that nature alone struggles to explain. Occasionally, we do find puzzles. A star might dim in an irregular, peculiar fashion. One famous case led some to wonder about a megastructure orbiting it, something perhaps built by distant beings. Further study suggested dust and natural phenomena could explain it. But the allure of that original idea, that it could be evidence of someone's grand construction, lingers in our minds. Another time, repeated bursts of energy arrived from a distant source, too brief and strong to easily categorize. Were they the flares of a magnetar, or conceivably the distant echo of some technology? We investigate each case thoroughly, unwilling to leap to conclusions, but also unwilling to miss any hint. These mysteries are like difficult whispers. One strains and wonders. Is that a voice, or just the wind? In our own solar neighborhood, we have also searched for life's traces, listening not with antennas, but with probes and rovers. We sniff at the red sands of Mars for the faint burble of microbial gases. We sample the water plumes jetting from the icy moon Enceladus and drill into Europa's frozen crust, hoping to catch a whiff of organic molecules. These pursuits, too, are part of hearing the cosmos. The universe might be teeming with simple life hidden in subterranean oceans or clinging to alien cliffs, and those small voices would be as meaningful to discover as any radio signal. A microbe on Mars, or a patch of alien algae in a distant sea, would whisper profound tales about life's ubiquity and resilience. And so we listen with chemistry and biology as much as with physics, trying to eavesdrop on nature's conversations wherever we can. So far, all our searching and listening returns a consistent refrain, a gentle hush, or at least nothing that conclusively announces, "We are here." It's possible that intelligent life is exceedingly rare, or tends to be short-lived, or perhaps communicates in ways we haven't yet thought to check. Some speculate that advanced civilizations might use channels entirely beyond our current grasp, or maybe they observe a kind of radio silence intentionally, like quiet watchers waiting for younger species to mature. We consider the Great Silence not as discouragement, but as an invitation to broaden our search and sharpen our senses. There is a certain poetry in the idea that, so far, the only voices we clearly hear in the dark belong to the stars and galaxies themselves. In the absence of confirmed alien signals, the cosmos still speaks to us in its own majestic language of physics and radiation, and we eagerly translate that to learn more about the universe. But beneath that scientific endeavor lies a very human longing, the desire to make contact, to share the night sky with someone else gazing back at us. And so, we continue to listen. We beam our own messages as well, like a lone singer in a vast emptiness, hoping someone hears. We have sent out coded radio transmissions aimed at nearby stars, time capsules of math, music, and information about Earth. We have packed greetings onto spacecraft that now journey beyond the solar system, golden records filled with the sounds and images of our world, drifting indefinitely through interstellar space. These are our whispers to the cosmos, our way of saying, hello out there, on the chance that someday, somewhere, someone might find them. Even if those missives are never intercepted, the act of sending them made us feel less alone, if only by kindling the imagination that they might one day be received. Perhaps the most profound aspect of this search is how it brings humanity together. When we collectively strain to hear a cosmic whisper, our differences fade a little. Under the umbrella of that grand uncertainty, are we alone? We find a sense of unity. The first signal we detect that is unmistakably artificial will be a message not to one nation or one culture, but to all people of Earth. Many of us sense that implicitly, and so the quest for alien life becomes a shared human endeavor, a quiet hope we all hold in common, whether scientist or casual stargazer. We can picture it now, one quiet night, as arrays of listening devices and telescopes go about their routine, a peculiar signal arrives. It's unlike any natural source we've recorded, perhaps a series of pulses with a rhythm or structure that stands out against the random noise. Computers flag it. Scientists double-check furiously. The pattern only grows clearer. In that moment, the silence is broken. The realization spreads across Earth like dawn. We have detected something, or someone, speaking from among the stars. After generations of dreaming and listening, we finally know that another intelligence is out there. How will we respond? What will we say? Those questions move from theoretical musings to urgent, wondrous reality. Humanity stands at the threshold of an entirely new chapter, one that part of us always believed would come, the moment when the cosmos is no longer a one-sided conversation. The faint whisper from the dark becomes a clear voice, and it is coming from minds not of Earth. Excitement, fear, joy, and deep curiosity wash over our world in waves. We prepare ourselves to reply, to reach back through the gulf of space toward this newfound companion. The long wait through silent nights has ended, and now the profound adventure of first contact truly begins. The moment of first contact arrives with a mix of trepidation and hope. After the initial shock of detecting an unmistakably alien signal, humanity gathers its courage and prepares to respond in earnest. We craft a reply with great care, encoding basic mathematics and physics, simple greetings in many languages, and invitations to communicate. When we beam it out toward the source of the signal, we know it will take years, perhaps decades, for our message to reach them, and more time for any reply to return. In that waiting, the world holds its breath in collective anticipation. We on Earth are bound together by the knowledge that someone out there is listening to us now. Every so often, telescopes pick up another transmission from the distant civilization, growing in complexity as they too learn how to speak across the stars. Slowly, a rudimentary dialogue begins, spanning light years and requiring a patience unlike any in human history. Each exchange is a small miracle, steady confirmation that neither side is alone or misunderstood. As information flows, even at its slow pace, we begin to learn about our cosmic pen pals. Perhaps they send sequences of symbols representing their scientific knowledge, or samples of their art, music or images coded into pulses of radio or light. We decipher their messages bit by bit, our best linguists and AI systems working together to find patterns and meanings. Likewise, we transmit pieces of ourselves, chemical formulas of DNA, diagrams of our solar system, photographs of humans and Earth's landscapes. What must they think of us, receiving these packets of who we are? And what do we feel as we absorb the glimpses they offer of themselves? There is a delicate courtesy in this exchange, each side careful, like two strangers meeting in the dark and slowly reaching out their hands. Over time, trust builds. The initial fears, will they be hostile? Will we offend them? Gradually ease as the conversation remains peaceful and full of curiosity on both sides. We come to understand that they too have questions and hopes much like our own. Their messages convey perhaps astonishment at finding us, relief that they are no longer alone in their corner of the galaxy. Maybe they had been searching just as long as we had. Across the vast distance, a friendship of minds takes root, constrained by slow communication, but profound in its implications. Both civilizations share knowledge of astronomy, of philosophy, even snippets of personal stories or cultural myths once a basic language is established. Each new bit of information is precious. We learn about the alien world. Perhaps it orbits a gentle orange sun and has a sky with 2 moons. Or maybe they live in enormous habitats, free-floating in space. We learn what they call themselves, what they call their home, and they learn the words human and earth. Then comes a day when a bold proposition is made, to meet in person. It could be initiated by either side. But let's imagine we receive coordinates, a rendezvous point in space, perhaps halfway between our two systems, and a proposed time far enough in the future to allow vessels to travel. The idea electrifies humanity. Sending an actual envoy to meet beings from another world face to face, or whatever equivalent they have for face, is a step as giant as any in our history. We prepare meticulously. An international team is assembled, representing Earth's diversity, scientists, diplomats, maybe artists, and spiritual leaders too, chosen not just for expertise, but for wisdom and calm temperament. Our alien counterparts likely do something similar on their end. Both sides know the first physical meeting carries tremendous weight. It must be handled with respect, caution, and goodwill. The journey to the meeting point might take years. Our crew, traveling in a specially designed starship, carries with them gifts and artifacts symbolizing our world. Perhaps a library of Earth literature and music encoded durably, samples of Earth's soil and seeds, art pieces that convey our creativity, and instruments or devices that showcase our technology. They also carry the profound responsibility of being the first humans to encounter intelligent extraterrestrials. One can imagine their feelings as the rendezvous draws near, hearts quickening with excitement and a kind of solemn awe. In their viewports, a strange vessel becomes visible, the craft carrying beings from another civilization. It may look utterly unlike any ship we've built, moving with an alien grace, powered by technologies we've only theorized. Our own vessel likely looks just as exotic and intriguing to them. In the final approach, both ships drift in a chosen quiet sector of space, far from any distracting gravitational fields, surrounded only by stars. The two crafts exchange gentle signals, perhaps pulses of light or simple radio tones, confirming that both are in position and ready. Then, in choreography, prearranged through earlier communications, they dock or station keep close by, and a meeting chamber is established. It might be aboard one of the ships, or a neutral module linked between the two. Wherever it is, that space becomes hallowed ground at that moment, the site of first contact incarnate. The airlock opens. Representatives of humanity step forward, and representatives of the alien civilization do the same. Here they are at last, not images on a screen or patterns on a graph, but living beings present before each other. Perhaps the aliens stand on tripod-like legs, or maybe they have no eyes but perceive the world through sonar or electric fields. Whatever their form, they are likely as wondrous to us as we are to them. Both sides knew roughly what to expect from prior exchanges of data. We may have traded images or descriptions, but the reality of the encounter still overwhelms. For a long, delicate moment, there is silence as each side simply observes the other, acknowledging the magnitude of this event. Then, someone, perhaps one of our ambassadors, raises a hand in a gentle, universal gesture of greeting and peace. An alien delegate responds with their own gesture, maybe a slow wave of an appendage or a soft illumination of their skin. Those become the first gestures of a mutual language born on the spot, a dance of understanding that transcends words. With careful movements and the aid of translation devices calibrated to both languages, the two groups begin to communicate. Simple phrases are exchanged, each confirmed by the translators and by friendly nods, or the alien equivalent, from the listeners. Despite years of remote communication, the first spoken words between species carry an emotional weight that is almost overwhelming. There may be tears in human eyes, and perhaps an analogue of tears on theirs, as the realization hits anew. This is real. We are meeting each other, and neither of us will ever be alone in the universe again. In the hours or days that follow, the initial meeting blossoms into a genuine exchange. We present gifts to each other. Imagine the aliens carefully cradling a globe of Earth, or a book of our art, while we receive perhaps an ornate object imbued with their culture's significance, or a device that showcases their advanced science. There might be laughter, or something analogous, as we discover points of commonality, or navigate innocent misunderstandings. Perhaps one of our songs is played, and to our delight, we find their auditory sense perceives the harmonies and finds them pleasing. Likewise, they might share something like music or visual art, and humans feel the hair on their arms rise at its beauty, despite its alien form. In those moments, we experience the joy of finding kinship in the unexpected. Naturally, practical matters are discussed too. We talk about how we might keep in touch more efficiently, possibly establishing a regular communication link, or even planning future meetings. But these logistical topics, while important, take a back seat to the simple, profound act of getting to know one another. Around a table, or whatever communal setting is arranged, humans and aliens share stories of who they are. We speak of our evolution from tiny primates and our journey into space. They recount perhaps how their species grew beneath crimson twilight or in emerald seas. We might not grasp every detail, but the broad strokes paint a clear picture. Both our peoples struggled through millennia, harnessed science, pondered philosophy, and looked up at the same stars with wonder and longing. As the meeting draws to a close, there is a sense that a new era has begun. The ambassadors part with words of friendship and promises to meet again. There is an exchange of farewells, maybe an embrace between species, or another solemn bow, knowing this parting is not an end, but the beginning of a long relationship. The ships slowly undock, each crew returning to their own vessel with momentous news and memories etched forever in their hearts. When our envoy comes back to Earth, they are welcomed as heroes, not of war or conquest, but of unity and peace. The entire planet watches their landing and listens as they describe the experience. The appearance of the aliens, the sound of their voices, the kindness in their gestures, and the plans laid for continued contact. Earth rejoices, not in triumph over another, but in the joy of connection. First contact changes everything, subtly and profoundly. Knowing with certainty that we share the galaxy with others transforms some of our oldest contemplations and fears. We can no longer think of humanity as the sole keeper of intelligence. We are now one among potentially many. This realization brings deep humility. Our perspective shifts. The dramas that once consumed us on our small world seem a bit smaller now, set against the backdrop of a vast cosmos teeming with life. It also brings validation to centuries of curiosity and hope. The lonely silence has given way to a voice, and we learn we were right to believe someone might be out there. For many, this knowledge instills a new sense of responsibility and unity. National and cultural boundaries on Earth seem less significant when set against the backdrop of cosmic citizenship. We might form new institutions or alliances to represent humanity collectively, speaking together when dealing with our new interstellar friends. Conversely, encountering the unknown face to face teaches us more about ourselves. In seeing how another intelligence thinks and lives, we reflect on the unique and universal aspects of being human. Perhaps the aliens have no concept of music and are delighted by ours. We realize how precious our art is. Or they have social structures utterly unlike any of our societies, prompting us to re-examine our own ways of living. Exchange of ideas may lead to leaps in understanding for both sides. New philosophies, scientific insights, even spiritual growth as we come to see more clearly our place in a populated cosmos. And what of fear? It likely dissipates greatly after a successful, gentle first meeting, although healthy caution remains. Over time, as trust grows, humans and aliens may visit each other's worlds. Picture a future where a spacecraft from Earth lands on that distant planet, or a vast habitat that was once only a point of light in our sky, and humans walk under an alien sun, escorted by gracious hosts eager to show the wonders of their home. In turn, perhaps one calm morning, an alien delegation sets foot on Earth, greeted by children offering flowers, and they marvel at our blue skies, green forests, and oceans glittering in sunlight. The barriers of distance and difference shrink in the face of genuine friendship. First contact is not a single moment, but a process, one that unfolds over years and decades, each step bringing us closer. By the time it truly sinks in that we have a mutual relationship with another intelligent species, humanity will have been transformed. The narrative of our destiny expands beyond the solar system. Our concerns and aspirations take on a cosmic dimension. We start to envision a future, not just where humans travel to the stars, but where we travel alongside companions from those stars. Ultimately, meeting the unknown teaches us that we can be a concept larger than humanity. The circle of those we consider neighbours, even family, extends to include beings that evolved on a completely different world. It's a profound expansion of empathy. We find that while biology and culture can diverge in astonishing ways, intelligence and the capacity for kindness create a bridge that can span any gulf. As we bid farewell to our new friends at the end of that first encounter, there is confidence that we will meet again. Plans are likely already in motion for continued correspondence, perhaps a shared scientific project or a cultural exchange program. What was once science fiction is now lived reality. The peoples of two worlds have greeted each other, and as both civilizations turn toward the future, they do so knowing the universe holds more wonders and more friends than we ever knew. With first contact achieved, humanity's journey among the stars enters a rich, uncharted phase. We are no longer roaming the cosmic ocean in solitude. We have joined a convoy, however small it may be to start. There is fulfillment in that knowledge, but also a sense of even greater journeys yet to come. Questions about who else might be out there, and how the tapestry of interstellar cultures may grow. For now, though, the success of meeting the unknown is a gentle triumph. It vindicates our hopes and validates our efforts. We dared to dream that one day we would say hello to others among the stars, and that day arrived, changing us forever. As humanity reflects on these events, we feel gratitude for the patience that kept us listening, for the wisdom that guided us to approach peacefully, and for the openness of mind that allowed us to embrace the truly different without fear. Having passed through the doorway of first contact, we step into a larger universe. The far future beckons with possibilities even more profound. Alliances between species, shared knowledge that could unlock cosmic mysteries, perhaps collective endeavors to understand deeper truths of existence. We can only imagine where this path leads. But one thing is certain. The children of Earth, when they look up at the night sky now, do not just see unknown stars. They see the homes of friends. The cosmos feels less cold and empty, and more like a community waiting to be explored. In the wake of this encounter, humanity stands taller and moves forward with a renewed sense of purpose. The long Odyssey that began when we first looked to the heavens has reached a new milestone, but it is far from over. In fact, in many ways, it feels like a beginning, the first dawn after a long night of solitude. With hearts full of wonder and growing confidence, we turn our gaze toward the deeper reaches of time and space. What lies ahead in the coming eons? With companions by our side and lessons learned from those who were once unknown, we prepare to embrace our ultimate destiny among the stars, stepping into eternity together. Imagine humanity 1,000,000 years from now, having travelled across uncountable miles and centuries. By then, the people of Earth are no longer confined to one planetary system or even one galaxy. We have become a presence as enduring and widespread as the stars themselves, in a way we once could only dream. Our descendants, whether flesh and blood or beings of augmented mind and body, live among clusters of stars and perhaps have touched the edges of other galaxies. They carry with them the legacy of Earth, the stories, the music, the curiosity. But they have also been enriched by influences from countless other worlds, and possibly other civilizations. In this far future, the distinct lines between human and machine, or between one culture and another, might blur into a harmonious tapestry of intelligence that originated on Earth, but has evolved in unimaginable ways. Over such vast timescales, even the stars move and change. Constellations shift beyond recognition. New stars are born, old stars die. Yet human, or post-human, civilization adapts and endures. We harness energies on scales that dwarf even the wildest dreams of our early space age. Perhaps we have learned to tap into the fabric of space-time itself, drawing power from places like black holes or the quantum vacuum. With such mastery, distance becomes less daunting. What was once a barrier of light years can be traversed with ease by methods that now exist only as theory. We might spread life to star systems that were once inaccessible, seeding barren galaxies with the flowers of consciousness. In doing so, we become not just citizens of the galaxy, but gardeners of the universe, fostering life wherever it can take root. Over eons, the physical form of our species may change dramatically. Through deliberate adaptation or natural evolution in varied environments, the children of humanity might diverge into many forms. Some may merge with advanced technology, choosing a path of digital or cybernetic existence, living as patterns of consciousness that flicker among the stars. Others might biologically adapt to new worlds, forming distinct branches of the human family suited to high gravity, aquatic life, or even the low pressures of space itself. And yet, across these vast differences, there remains an invisible thread of shared origin, a lineage traceable to that small blue planet that once orbited a yellow star. In gatherings 10,000 years hence, or 1,000,000, when beings of many forms and backgrounds come together, perhaps they still tell the ancient tales of Earth, much as we today recount myths of our distant beginnings. Earth's memory becomes cosmic lore, passed on so that even as we become more than we once were, we do not forget where we began. In this far-flung future, we have likely encountered many other life forms beyond that first civilization we met. The universe may be peppered with intelligences, each at different stages of development. Some could be far older and wiser than us, having survived challenges we have yet to face. From them, we might learn how to navigate the death of stars or the drifting apart of galaxies. Others could be younger, just stepping into space. To them, we might be the elder guides. Think of that. Humanity, once the novices in a galactic community, becoming the experienced explorers who mentor newer species finding their way. With each new contact, the web of relationships grows, until perhaps a vast fellowship of civilizations exists. Not a centralized empire or anything so rigid, but a loose harmony of beings, recognizing one another as fellow voyagers in the cosmic ocean. Life in this epoch is rich beyond the scale of any one planet. Habitats and settlements are sprinkled through space like dew across a morning field. Some communities drift freely between stars in colossal world ships, content to wander indefinitely. Others anchor around stable suns, creating paradises that last for millennia. Communication that once took years between stars might happen nearly instantly through technologies that link distant points of space, perhaps by entanglement or other means we have yet to discover. Shared knowledge, art, and ideas flow across light years as easily as thoughts across a synapse. It may be that consciousness itself is not bound to individual brains or bodies. The collective knowledge of civilizations could form vast networks that span regions of space, subtle and grand. With such advancement, even mortality might become less absolute. Individuals could live for very long spans, or through cloning and digital mind states, one's experiences might be preserved and continued. The fear of death that haunted our early history might diminish as we find pathways to maintain continuity of self. Some might choose to move on to new forms deliberately, shedding old bodies like a butterfly emerging from a chrysalis, stepping into new ones, grown or built to suit their fancy. The result is a kind of eternity in which life, in one form or another, persists and evolves without a clear end. As we reach farther into time, we face the grand stages of cosmic evolution. Stars age, galaxies collide and merge. Far in the future, our own galaxy's stars will eventually burn out one by one. But even then, a clever and cooperative civilization can find ways to survive. We might migrate to younger star systems, or build enormous reactors to create new light, or tap the energy of black holes spinning in the darkness. It could be that life, once ignited, finds a way to keep the flame burning against all odds, perhaps even lighting new flames in new universes, if such things are possible. By then, concepts that sound like science fiction to us, harnessing dark energy, moving between branes of reality, might be within the realm of the possible for minds far beyond our current comprehension. But perhaps the details of such extreme futures are less important than the mindset we will have gained. Imagine the perspective of our distant descendants. They see the universe in all its grandeur and know it to be home, fully and without reservation. The youthful fears of the dark and the unknown have long been laid to rest. The questions of loneliness answered by countless voices in the sky. Their concerns are no longer mere survival, or even exploration for survival's sake. By then, they explore as a form of creation, adding meaning to the universe as much as discovering what is already there. They might compose symphonies in the arrangement of galaxies, or create art on scales that involve entire nebulae. With practical needs largely met by advanced technology, curiosity and creativity become the driving forces of existence. Perhaps they devote themselves to truly understanding reality at the deepest level, uncovering layers of physics and philosophy we cannot yet fathom. To them, concepts like time and space might be malleable playthings, just as once fire and stone tools were to us. Through all changes, one constant remains. The spark of wonder kindled in our species long ago continues to burn. It's the same wonder that led an early human to look up at the stars with curiosity, the same wonder that urged us into space, and the same that now pushes our far future selves to roam across cosmic eternity. In that sense, the soul of humanity, our desire to know, to love, to create, achieves a kind of immortality, even as the forms we take and the worlds we inhabit change. We have carried the flame of consciousness to places those first stargazers on the African plains could never have imagined. And we keep it alight, sharing its glow with every new horizon, spreading its warmth to new worlds and perhaps new minds we encounter. It's beautiful to think that in the unimaginable future, someone, whether still human or a being evolved from humanity, might stand on a hill under an alien sky and remember the journey that brought them there. Perhaps they will tell a story that begins, once upon a time, on a planet called Earth, and recount the epic of how life from that blue world spilled out into the cosmos. Maybe they will have listeners from multiple species sitting together, enthralled by the tale of ancient Earth and its courageous children. That story, our story, will by then be one thread among many in the tapestry of civilizations. But it will remain uniquely ours, a testament to how far determination and curiosity can carry an intelligent life form. Eventually, even the concept of an ending might lose its meaning as we approach something like eternity. If the universe itself has an end, perhaps by then our collective wisdom finds a path to whatever lies beyond, a new universe, a higher plane of existence, or something we lack words for entirely. Or perhaps we accept that end, content that we participated in the grand play of creation for as long as possible, and ensure our legacy seeds new beginnings elsewhere. In either case, the spirit of humanity, which by then has intermingled with the spirits of countless worlds, will not flicker out without leaving a mark as lasting as the universe itself. Standing at this vantage point of thought, looking from the present toward that vast horizon, one thing becomes clear. The journey of humanity has always been defined by reaching for more knowledge, more connection, more understanding of the cosmos and ourselves. Every step, from the first stone tools to the first starship, has been driven by that restlessness and hope. In the far future, among the stars, that same force carries us onward still. We realize that there was, in truth, never a final destination. The Odyssey itself was our purpose and reward. Each generation finds a new horizon. Each achievement opens doors to new questions. We evolve, we discover, we create, and in doing so, we bring meaning to the silent depths of space. As our tale draws to a gentle close, this image lingers. Humanity, changed in form, expanded in mind, joined by friends, moving gracefully through the cosmos with wisdom and compassion. We see ancient stars reflected in the eyes of our distant progeny, who have witnessed sunsets on countless worlds and the glow of galaxies beyond our own. We sense that, in some profound way, the universe has become self-aware through our journeys. The atoms forged in stars coalesced into beings who can appreciate the stars. In that sense, we, and any others who travel with us, are the universe's way of experiencing itself, living threads in the tapestry of existence, stretching outward and onward. And so, our 4-hour Odyssey finds its calm conclusion, not in an end, but in a continuation, an endless road stretching out among the stars. The vision of humanity among the stars is not a final chapter, but an ongoing story written across time and space. As you drift into sleep or contemplation now, think of that vast, starry expanse, and know that in a time far ahead, the legacy of all of us is out there, shining and alive. The cosmos cradles us, and we in turn give it meaning, in an exchange destined to last as long as the stars shine, and perhaps far beyond. In this gentle understanding, we find peace. We are home among the stars, and our journey continues forever.